Thank you for letting me know that. Is the sound now working? And I just realized that the sound wasn't working. I have to do that entire introduction again. That's also the wrong water bottle I'm grabbing. Yeah, sorry about that. So we're off to a wonderful start if I've lost sound right away. I'm now checking. Okay, on my side I can hear sound again. I've just have it playing in the background. So I'm going to repeat everything I've just said over the last 3 minutes. Welcome in, everybody, and hi, my name is Zach. I totally skipped that, actually, in the original introduction for this. This series is going to be a bit different than my other live streams. In fact, welcome to one of my, until now, rather infrequent live streams. What I plan on doing moving forward from this point is to have at least bi-weekly, so once every other week, at least. I will try to do more live streams. These live streams will... Thank you very much for letting me know that the sound is working now. These live streams will be a bit different in that, well, usually when I've done live streams previously, I've had a plan. Outside of the UE5 one where it says, hey, UE5 came out, let's test it. I usually have a plan. You know, I come in with some prep code, knowing what I'm doing. These live streams will be different. I will not typically have prep code. Today I do have a little bit, but we'll talk about that in a moment. And I'll be focusing on one thing primarily throughout these live streams. But today we'll be doing a couple of things. And in fact, one of those things might show up a few times. So today, for the first part, besides this introduction, which I'm redoing clearly, we'll be working on a neural network. Now, I've written neural networks before. I've worked with neural networks, you know, TensorFlow, and other machine learning libraries. I've written my own, as I said. I want to write another one, so we're going to do a bit of that today. Want to test some things out. I'll be making the code from today from the neural net publicly accessible on my GitHub. I realize I rarely do that, but hey, we'll be doing that for that. The other thing, the surprise thing, is overwhelmingly based on the votes, you all want to watch me suffer. We'll be making our own game engine. Now, before we get into that, sorry, I will be drinking water, and as I said earlier, ironically, also a Monster, or unironically, I guess. I've never done a game engine. To be fair, I have no idea if I'll succeed. I have no idea what I'm really doing with it. I'm going to be doing it as a learning experience for myself, which I'll be sharing with you via these live streams. To do this, what I am going to do is I'm going to follow multiple tutorials that have already been written. Some of them will be on YouTube, some will be from GitHub, some will be from blogs. So for like GitHub, there's the Raycaster one, which is 4 tutorials for. I'll be doing at least one of those. There's a few DX11 blog tutorials I've seen, and there's a couple on YouTube for in C++. There's one in Java from a really good YouTuber, but since I don't do Java, or I don't like working in Java, I'm not doing that one. So with those, as I progress, I will make the code for those engines from the tutorials that I am doing publicly accessible if the tutorial creator allows for that to be done. If they don't, I won't. In addition, I'll be sharing the links to the videos, blogs, what have you that I'm following. Once I've gone through a few of those tutorials, once I've gone through the DX training, all the other stuff, once I've looked at OpenGL a bit more, gone through some of their training, we'll take a stab at making our own engine. With that code, we'll talk about what we'll do with the GitHub and things like that. So, yeah, it's going to be a learning process. That said, what this means for the series overall, this live streaming bit we're doing now, is that there's no script. Usually I come in here, I have a script. I have a prep file off to the side. I know what I'm going to be doing. Today, we're iterating some previous code, so that shouldn't take too much effort, too much explaining. I can walk through it. But when we start working on the game tutorial, or the game engine tutorials, you got no idea what's going to happen. And we're going to find out together. So that said, welcome in. And if you're watching this as a VOD, do remember again, this is going to be very different than my normal videos. Well, one, on my camera, that's rare. And two, yeah, it's going to be a little bit more hectic. So that said, strap in, and we'll make a start. Okay, so yeah, sorry, I always do the little intro thing. I should have used that moment to open the can of Monster, but hey, you're all gonna hear that open now. So I'm gonna start with our neural network, and I already have Visual Studio loaded up in the background. And so what we'll do is we'll create a new solution. I was gonna say new repository, but we're not at the repo stage yet. So I'm just gonna drop this in my programming folder to neurons, and we'll do this under YT live. And yeah, well, I think I just said open instead of create new project. That's what I meant to click. Be helpful if I was paying attention. We'll do empty next, and this will be YT neural project. At least I created the folder I'm going to be putting it in. So that's in our 2 neurons live stream folder. All right. There we go. You know, I actually did mean to have this one folder deeper. So I'm going to really quickly, like I said, welcome to live streams. I'm going to be making some of these funny mistakes. I'm going to very quickly close this up. I'm going to create a new folder really quickly called Neural Net. Let me just close that, and so you can see what I'm doing. I've created the folder. There we go. Hopefully that should still work. If not, whatever, I can recreate the project. Not like the stream isn't off to a wondrous start already with the sound not working and all that fun stuff. All right, let's go to, no, I don't want collapse all. Let's go to the actual view. And I'm gonna add in no, that's not what I meant to click. I don't want the cookie cutter, go away. I want to add a new folder. This will be called includes. And another new folder called source. Oh yay, my E key is doing the weird thing again. That's gonna be fun. Let's go to our properties here and just make sure that this is set to, I want to do C++20. There might be a for loop option I want from C++20. Otherwise, C++14 and 11 are fine. And we're going to start today with a utilities folder, or utilities file that we're going to be creating that will take care of some stuff for us. We'll be using it for our math functions. And this is one I typically create in most of the projects I work on. So this will be something, yeah. This will be something that you'll have seen me probably do previously if you watched any of my coding before. Sorry, I am actually looking for my notes on this, and I just found it. Okay, so we're going to create within each of these a folder called utilities. Actually, I'm going to call it, yeah, utilities. All right. So within here, we'll create our header, and of course, this will be our implementation file. Actually, we don't need, yeah, actually, we do need one of those there, but we won't use it right away. Actually, we might. All right, let's just start with the header really quickly, just while I think about my choices here. All right, so we're going to start with my usual math utils. Okay, so that's not what I meant to do. Or is that what I meant to do? Let's just fill this in really quickly with a whole bunch of asterisks just so I know that this is a math utility function library, a collection of math helpers or helper functions and structures. Original code by DJ Parker, 2 neurons. You're gonna be on my GitHub. You're gonna have my name anyway for his YT channel. Okay. So first thing we're going to need is we're going to create a namespace that we're going to be using. So we're going to use a namespace called umath. There we go. And I'm just going to copy that for a moment. And that. I'm lazy. Makes my life easier. Okay. And what this is function library common math functions. These functions are intended. That is not meant to be in all caps, sorry. The first part was these functions are intended for general use across all classes. There are no specific use cases for these functions. That's actually not fully true, but meh. All right, so I'm gonna start with my ratio functions. So what we'll do here is we're going to return a ratio of a value, comma, between 0 and 1 inclusive. All right, so we'll do an inline float get ratio float raw value float minimum float maximum. Now, when you're editing these values, you could pass them in as references. I'm just going to copy them for now. We can talk about iterating into references later. We're going to check if the raw value is somehow greater than the maximum. If it is, then what we're doing is we're just returning 1. So we return 1.0f, raw value is equal to or greater than max, so ratio is 1. All right, next what we'll do is an else if, and we are checking is the raw value greater than the minimum. And I forgot to put a semicolon in. There we go. And so what we'll do here is we'll return the raw value minus the minimum. So that is what we actually scored over the range of possible scores. So maximum minus minimum. All right. And then we're just going to put a catch-all. And this is our return 0.0. And this is literally just a catch-all. So this is our standard ratio calculation. Nothing fancy there. It does exactly what it says on the tin. We don't need to really think about it. Yeah, you mean the fact that my eyes can carry my groceries home? Yeah, I know. That is a permanent feature of my phrase. I'm not entirely sure what a phrase is, to be fair. But apparently I have a phrase. By the way, welcome in, Chika. See, at least that time it wasn't intentional. All right. So next what we want is we want to return a +1 or 1 or a -1 based on the sign of the variable we're passing in. And in this case, we're going to make this a bit agnostic, so we're going to use a template. And we're going to say that 0 is a positive, so basically return positive or negative. We're going to say 0 is a positive value, so it returns a 1 or a -1 based on the relation to t, which is our template class. Sorry, relation of t to 0. 0 is returned as a 1. So we're going to do template class t. Actually, I'm going to make that an uppercase t. Inline static t value sign will be our function name. We're going to pass in the const of t, which will be denoted by the variable x, and we're going to return is x greater to or equal t cast of t 0. If it is, then t is +1. That's what we return. If not, then we cast a t and return -1. So remember, we're typecasting there. How are you doing, by the way, everybody in the room? Juan, Chica, everyone doing well? Okay, so once we've done that, we're going to do one that will check for odds and evens. Should be really simple. If you've done anything in C++ before, you probably tackled all the things we're currently doing, or some version of them. So we're going to return a true for even and a false for odd. And again, we're going to use template class T. We're going to do inline bool check is even, type T, and X. In this case, we can't use a const because we're going to do some multiplication. Sorry, we're going to do some modulo stuff. Now, I know before we go forward what headers I'm going to need for this. I know I'm going to need my random CMath set and standard exceptions. For now, I think it's the CMath one I'm going to be needing because I need the fmod. So there is CMath included. Hey, Manny the Pirate. I am feeling a bit out of sorts with not actually having a script in front of me for what I'm doing. It's kind of weird. Also, the fact that in my screen, I'm in like 2K, and on the stream, it looks like it's not even 720 is a bit horrifying. It is 720 according to this. You should be able to get it at... you can't change it to 1440. Cool. Sorry, I was just playing around with the stream on my side now. All right. Sorry, I've lost the chat window, and I'm trying to get it back up on my screen. Really? Really? That's useful. Okay. Sorry about that. There we go. Sorry. Now I have the chat back on my screen properly so I can see it. So what we'll do for this is we are going to do an if statement, and we're going to use the fmod, which is why we included that. We're going to take x, and we're going to divide it by 2. We want to know, does it have a return value? If it doesn't have a return value, so if the return is 0, then of course this is an even number. So we return, not sure why I included brackets for that. So we return true. Else, in other words, it's odd, or that's a false statement, it does have a remainder, then we do a return false. Okay, it is readable on phone. That is really good to know. I'm assuming you're driving somewhere right now, or walking somewhere. All right, so there is that done. We're going to create some random number generators. So I'm just going to steal this one, paste this down here, get rid of that extra space I put in there, and then this one will be our random, or actually pseudo, since, you know, pseudo-random number generators. So this is PRNGs. And let me just quickly do this bit. These struct stroke functions are designed to generate pseudo-random numbers. There are different approaches that can be used for different use cases. So I'm going to implement 3 pseudo-random number generators. We're going to start with our seeds, which we'll try to use across all 3 of them. So we're going to do, for our seed, inline uint, so unsigned integer 64, seed generator. And we're going to pass into this a uint 32t seed. We're going to call this seed in, and we're going to default this to 0. We'll do a bool called bUseOverride, which we will also default to false. So we're going to have 2 defaulted parameters we're passing in already. There we go. And what we'll do is we're going to do first, if we are not using the override, so in our normal case, we are going to get a distribution of random numbers. So we're going to do std, and now we need the random library actually. So this will be include random. We're going to do std, so standard random. No, it was right earlier. I had device highlighted. Random device, and we're going to store this in rd local. So random device local. Where they're going to use the, I can never say the guy's name right, Miser Twist 19937 for the generator. And we'll pass in RD local for where this is going to be written to. There we go. Nah, I'm just on the phone, falling asleep on PC, but can't go pick up my kid yet because there are 10 separate crashes in my area. Lovely. That sounds like what I expect for your area, to be fair. Also, based on what I was shown of the roads the other day. And then from there, we're going to get the uniform distribution for the integers. We're going to pass in our type as uint. It'd be helpful if I didn't type in unit. Uint, so unsigned integer, 32-bit. And this will be our possible seeds local. And we'll give it a range of 0 to 10,000. Okay. And then we set the seed value by returning possible seed locations and our generator, which will give us a single value. But we have this other condition. What happens if we aren't using this? And we're going to take whatever is here and use that instead. So else, what we're going to do is just return seed. Actually, seed in, sorry. So this returns a seed provided by the user. All right. So that is our seed generator. What we're going to do next is our XOR shift structure. So we're going to have our XOR shift random number generator. And this will be a structure. So let's call it S for structure, random very fast. I like verbose names, by the way. It just makes my life easier. All right. So this is a structure. We're going to start with some variable types in our structure. We're going to put them in the scope of private because we will have some things that are public. And this will be uint64. And we're going to start with a value called t, which is just going to be used for storing... hang on. Give me 1 second. We need a shuffle table, which is an array. We actually don't need a shuffle table. I'm going to do a shuffle table, which will be an array of 4 integers. So we don't need those 4 integers. We're going to have a results table. We're going to have our shuffle and seed. We're going to have our seed. We have the override. What is T for? Why do I have a T? I don't think I actually ever... I don't think I need this variable I was about to create. Also, let me just put that bracket back in and delete this old one. All right, so instead what we're going to do is the array I mentioned while I was rambling to myself, not 16-bit, Jesus, 64-bit, and this will be shuffle table. It'll be an array that is 4 integers or elements long. We'll initialize each value to 0. Then we'll have our result, and I said that was going to be a table. I don't know why I said that was going to be a table too. It's going to be a single value. Manny, I've been playing. It is actually great timing. I'm planning to do this for a while. It's just been something that's slipping my mind, so I've finally got into it. Hopefully, watching someone do it live, you can see that even as I'm doing it, going, oh no, that's not right. I have planned this out slightly, so I do know this bit. So result, we're going to just initialize to 0, just so we have something initialized there. Oh, wait, hang on. What the heck is going on here? Okay, there we go. Sorry, I just realized there was brackets that, yeah, I wasn't paying attention earlier. And how is it going with the learning, by the way? And then we have uint64t, and this will be our actual function here. So this will be XOR shuffle, in which we'll pass in an argument of uint64. Actually, it's 32t seed in. And we'll declare or define that later on, and we'll give access to it later on as well. Then we're going to do uint32t seeds. I'm not sure why I said seeds. Seed singular. And then we're going to have a bool called b use override. And we're going to default this to false as well. In fact, actually, I'm going to go back and change something in a second once I fix that typo. This is going to be use override in. Let's pop this open, paste that into there. That way I know what the variable is versus I know what the function is. Yes, I know this is undefined. Thanks for letting me know. Actually, let's very quickly define that, and then we'll return to the rest of the structure. This structure is nowhere near done. We're going to make this a structure that will handle various different calculation types for float and what have you. All right, so what we're going to do is we're going to build the shuffle itself. So we're going to go down here, and this is going to be inline, and we're returning a uint 64-bit. And it's called XOR, actually, sorry, no, we have to use a namespace. So it's S random very fast XOR shuffle, in which we're passing in uint64. Now I can copy and paste a line from above. I really felt like it. I should have, by the way. Seed in. And what we're going to do here, I see what's gone wrong. There we go. You shouldn't be giving me that issue. Why is the definition incompatible? Oh, 32-bit. Okay, there we go. Woo! Alright, so to be very clear, and you can get this code that I'm doing online already, this is the next function from the original XOR shift generators, except for I've changed it out with minor variations. So I've changed out, instead of having 4 integers, I have a table, an array that I call the shuffle table. So we're going to take the shuffle table, we're going to set the first element to be equal to seed, which has an extra E up here. Okay. We are then going to set the value at the first element, or element 1, so the second element, to be 362436069. So 362436069. Yep. And then for the third element, so shuffle table 2, it is going to be 5212. I really wish I had this on the screen in a way I could read it easily. 88629. Sorry, I have the PDF open over there. The Wikipedia article is actually easier to read. And then what we're going to do is start doing our XOR shuffle here, or XOR, yeah. So we're going to do shuffle table 0, and then we're going to use that operator with shuffle table 0, and we're going to use the XOR. We're going to do the shift 16 bits on our left operator. We're going to copy this down here and paste it twice. Except for this, we're now going to shift in the other direction. And we're going to use 5 and 1. I do need that other variable. Sorry, I need a place to store this part of the shuffle table, and that's what that was. Okay, so we're actually going to declare it down here so I know what it's for now. uint64t. We're just going to call this t. We'll default it out to 0. So now we're going to take t here, and we're going to take whatever is stored at shuffle table 0, so our first element, and we're going to store it there. So this is going to be what we use in a little bit. Actually, I don't think we even do anything with what we're storing there. I'm just getting rid of it. No, I don't. I come back to it. I'm storing it for later use. This is a temp variable. That's why I named it T. At least that's why I think I named it T. I can't remember if I actually copied that from the original one or not. So what we'll do is we'll do shuffle table 0 is now going to be set to be equal to shuffle table at the first element. We're just literally shifting everything down by 1. So I'm going to copy that, paste that into there. This becomes 2. That becomes 1. So everything's shuffled down. Technically, this should be 3 now. Nope, not 2, 3. You could use the fourth one as a replacement for t instead, if you really felt like it. In fact, actually, let's do that. Just gonna comment that out for myself in case I decide that this does not work. So shuffle table three. So 1, 2, 3, 4. So shuffle table 3 here is now going to be shuffle table 0. There we go. Now we're shifting everything down. So what we're going to do here at the very end is we're going to take shuffle table 2, so our third element, and we're going to take shuffle table 3, where we just stored the original 0, to the power of shuffle table 0. Oh, that should not be an ampersand. We're not modular, I said power. Shuffle table 1. There we go. And now what we do, just so that we can make our life a little bit easier, we're going to store it in a result. And this will be our shuffle table 2. And then we can return result. Okay. So that is the actual random number generator right there doing its thing. Beautiful, right? Confusing as well. I have read that paper so many times that I don't even fully understand the math behind. I mean, I understand the math conceptually. I don't understand the math at all. All right. What I want to do now is I want to come back into our sRandom very fast here, so our structure, and I want to create how we can call this up. And first, I need another variable. I'm going to declare maxRand. I'm going to override the default maxRand, so it's going to be int 64t maxRandom, and I'm going to use the memory address of 0x7ffff, which I believe on my computer, based on my earlier test, is 32,767. That number actually seems a bit small, but whatever. So now we're going to create our generator for calling up the structure. So we're going to create a constructor for it. We'll do this in the public scope of sRandom very fast. And what we need is the person to pass in a seed. So we'll do uint 32-bit t seed in, which will default to 0. We'll do our bool of b use override in, which will default to false. Not sure why I'm putting semicolons there instead of commas. And then we'll do uint 64t max in, and we will just pass in that as a default. All right, so then we're going to do a conversion to float, which returns a random float between 1 and 0 with 1 exclusive. So this is conversion to float, returns random float between 0 and 1, 1 exclusive. All right, so we're going to do operator double. Done having that weird E issue. So we're overriding the double operator for this. And we're going to return double XOR shuffle. And we're going to pass in the seed generator with our seed, which, by the way, we haven't set yet. So right now this is still 0. And our B use override. Now it could be set up here, by the way. But I actually forgot to construct this constructor. Sorry, I'm thinking class file, not what I'm doing here. All right, so what we'll do here is do seed in. I am so glad I made that comment. B use override is equal to B use override in, and then max random is equal to max in. All right. Okay, and let's fix that typo down there as well. And then we'll take, sorry, I'm making sure on the right side of the brackets, it's, hang on, I gotta do it this way. Outer, not that one, that one. Okay, it is the second, or between the second and third. So then we'll have it multiplied by 1, and then we're going to divide by, well, a really big number. I literally just multiplied pi by 1,000, moved the decimal place over, not by 1,000, by a random amount. That's all I did. I Googled pi. I have that on the other screen. So it's going to be 314159265358979. There we go. Not sure what G was there. Sorry about that. All right, so that is for our conversion to a double or to a float. We will then do our conversion to int 64 returns random int 64-bit between 0 and max random max inclusive. All right, so what we'll do here is, again, we'll use the operator and we'll overload uint 64t, and then we will return XOR shuffle. Now we don't need to use a type here because it already is a uint 64. And I'm just gonna cheat a bit and copy this first part. There we go. And then we're going to use the modulo, and we'll use max random there. Ooh, I actually should have that on the outside of what we're returning. There we go. Max random. Please override. Return. Return XOR shuffle. Oh. I copied more than I realized. Okay, there we go. So, yeah. Let's just try that out. All right, so we'll cast to a double type, then we'll do the multiplication. Hey, Hanas, give me 1 second, guys. I need to take a quick step away from the screen. I need to actually very quickly get more water because my water bottle from earlier, so I switched over to the Monster, is empty. And I'm going to have a quick smoke break as well. Be back in a moment. Sorry about that. I do be back. I will be having the camera back on in just a moment and the BRB thing off once I figure out which button I pressed. There we go. I pressed earlier to have that up there. Sorry about the delay. I am back with a new bottle of water. That's much heavier than I thought it was going to be when I tossed it without paying attention. And let's get ourselves back to coding. Okay, so, yeah, again, my apologies about that. Let's see. What we've done is we've done our first two main conversion types there. All right. Sorry, I'm just moving the monster over. I want to address some issues with the handedness of the operators. So I want to make sure we can do left-handed operations as well as right-handed, I guess. And I'm just going to try to find my notes for that. Sorry, you're going to see just random things pop up on the screen for a moment there. That's a note for something else. I think this might be what I'm looking for in my notes. No, this would not be what I'm looking for in my notes. Give me 1 second. Like I said, the joys of live streams and not having scripts for them. You get the randomness of me just sitting here going, I have completely missed something that I need. What have I done with it? Kind of like screaming like Wash and Firefly. Who's flying this thing? We're doomed. We're all gonna die. Who's flying this thing? All right, that'd be me. Was that Funeral? Yeah, that was Funeral. The last filmed episode they had before the series. Yeah, sorry, it took me a while to find a cold water bottle. I had two of them in the fridge since this morning. One was still like room temperature, and the other one was cold. It didn't take me a while. I just wanted to figure out what was going on with my fridge before having my cheeky cigarette. I mean, I don't smoke. Smoking is bad for you. Don't smoke. Right, so give me 1 second just to find the thing on my note on what I was going to do. Because this one is iterating off some of my older code, so I do know kind of where I wanted to go with this. Genetic algorithm. I've put it in that folder for some reason. All right. 64, did that one. All right, so we're gonna do right hand side assignment operators. So what we'll do here is we'll do assignment operator. Actually, we're gonna no, we're not gonna do any of that. That was for something I was doing completely different. We're not gonna do any part of that whatsoever. No. No siree. No. All right, so now that we've done this, we can, I think we're done with this actually. Yes, we are. All right. Boink, boink. Nope, too many. All right, so after our XOR, we're gonna have our LCG. So this is our fast random number generator, or pseudo-random number generator structure using the linear whatever it's called, congruental generator, LCG. All right. We're going to copy the same pattern as we have up here. In fact, actually, just to make my life a tiny bit easier, we're going to take all of this, and we're just going to copy it down here. And we're going to just change out vary to fast. We're going to get rid of our shuffle table. We're actually going to get rid of our result. Okay, we're getting rid of a lot of this. I realize. Actually, we're moving some of this around. We're going to keep seed. We're going to keep our B use override. And in this case, this one is actually going to be a static. No, it isn't. I lied. we're going to do it the same way as we did before. All right, so this is, well, we'll actually take care of that in a moment. We're going to declare the function we're going to use for this, which will return a uint64t, get fast random, and it will pass in a uint32t seed in. All right, and that should be uint, not uy, whatever that was. No idea. Okay, so this should be fast. There we go. All right, all of that stays the same. We come down here. This will be get fast random. We will still use the seed generator. We'll still use the same multiplier and divider. And then this one will be get fast random as well. And that all remains the same. So now let's come down. Where are you? You are to this bit, aren't you? Yeah, you're to the structure. Good. Let's come under the structure and do inline uint64. Sorry, I had to double check it wasn't 32 for some reason. Get fast. Oh, nope. S random fast. Get fast random uint32 t seed in. We have no issues. I did match. I could have just copied that bit. All right, so this is just our slope function. So y equals mx plus b. And we're solving for y, where y is a random value. So in this case, it's an increment y equals mx plus b. So it's multiplier times x plus increment. So what we're going to do is we're going to set a seed, and we're going to do this by taking the seed we're passing in, either being the random one, and we're going to multiply it by a multiplier and an increment value. So that is what the actual seed for this is. And that will be, and this is coming from the LCG original algorithms themselves, will be 1664525. This is a long times seed plus, sorry, that should be seed in. Now that will be seed. This will be seed in. That took me a moment. Sorry about that. And then 1013904223L. All right. And again, values from the LCG algorithm. Y equals mx plus b. Okay. Now that we've done that, what we're going to do is create a local int. So we'll do int 64-bit, and this will be int local, and we're going to use addresses of memory. Again, I'm lifting this from the original LCG paper. You can find a copy of that paper and the numbers I'm using on Wikipedia, actually. I'm not joking about that. They're legitimately on Wikipedia, and they're the original papers. And I think it's, actually no, it's F00. 1, 2, 3. Nope. Yeah, that's right. And then we'll use another memory address. And then that's 1, 2, 3, 4, 5. Okay. And then we return int local -1. Okay, just gonna double check this. Give me a second. Yeah, that should work. Sorry, the reason why I was pausing is I want to make sure that this was not seed in. So what we're doing is when we call this up, we call this bit, we construct it, return. So we're passing the seed here. We set the seed if we're setting the seed. That's the part I was more worried about than the random seed. So let's say we set this to 0, right? We call this up, we pass in here, we've overridden our seed here. So we come into this bit. All we're doing is returning the 0. And then we come down to this bit and we pass a 0 in. And what we do is we're multiplying that by 0. So the seed then becomes this lovely value here. Right, time for some water. All right, what am I getting here? Okay. 4-bit value. Okay. So what I'll do here is I'll try to typecast to uint 64 T. I'm plugging in that error, aren't I? I'll do the entire thing in that. Yeah. Arithmetic. Okay, there we go. All right, so those are 2 of our pseudo-random number generators down. Just gonna check my notes from my earlier project with something similar, if there's anything else I want to add in. I don't think there will be. I think we'll be on to our 3rd pseudo-random number generator in a moment. But I am just gonna double check that I have not forgotten anything. It does not seem like I have. And then we're gonna create a random slow, as I'll call it for now. And this will actually be based on the standard rand approach used in the standard library. So this will be slow random number generator using the name I can't say, Twister. And so this will be struct s random slow. And we'll start in the private scope. And again, we'll do our sorry, I am just double thinking my structure here. Give me a second. That's for later. By the way, if you don't know what that is, if you need handwriting samples for machine learning, good site to use. Also, there's a LinkedIn page that has the same thing. I was trying to find handwriting samples earlier today for something I was testing. What am I looking up? Oh, I am looking up the values for the whatever that thing Twister is. Cerny Twister? I don't know actually how to say that name. I really don't. And it's kind of embarrassing. All right. So for those of you who don't know, this is what I was looking for. Just looking to find the values in here really quickly. So by the way, this is what we did earlier. We're going to be making our own version of this. Actually, you know what? No, we're not. We're not going to make our own version of this. It looks cool. Like, it really does look cool, making your own version of it. As cool as coding can look. But we can just use a dang rand function. Yeah, I always wondered, if a random number generator, if ever saw me doing a random number generator, how they would feel about that. We still have random number generators we're going to be doing in this. We're just not going to do the one that's based on the rand one. It's already built into the dang random library. So instead what we're going to do, instead of that, we still have other rand functions we need. So we have our get random fast. We finished that out. We have our structure. No, we have a structure that we're about to delete because we're not going to use it. We want to get random double. So what we're going to do for that is we're going to return a random double, 0 to 1, or 0 to 1 in this case, 0 to 1, 1 exclusive. And if you don't know why 1 exclusive, this is a exclusive. If you don't know why this is exclusive, this is a double. Well, how do those things relate? Well, if we go back to our doubles in either of our random number generators, remember, it's 1 exclusive. So whenever we have a double, it's 0 to 0.999 repeated. Right. So this is meant, it does have some use cases. What I'm using it for, it is meant for minor application and other math utilities. Okay. Utility. Okay. I really need to get a spell check for this. All right. So what we'll do is we're going to do an inline double, random double, and we're going to just pass in bool be use very fast. We'll default this to true. And these defaults in this one is more for testing. This is also for testing, but we will give the option for users to override it. And what we'll do is we're going to return 0 to 999, divide this by, and then we're going to convert that over to, okay, returns 0 to 999. We then divide to get a range of 0 to approximately 1. And what we're going to do is if be use very fast, and then we'll come down here and do else. Okay, so what we're going to do here is return, and because this actually is just going to be one line, let's just do return to make this. All right, return double, and then it's going to be s random very fast modular operator 1000 divided by 1000. All right, there should not be a second thing there. Else what we're going to do is, well, we could really have used an enum here potentially. We could have 3 outcomes here. We could have very fast, fast, or the built-in MT one. So for this, let's do return double s random fast. We are going to, and notice in this case, we are using the default arguments. We're not allowing the C to be overwritten for these two. We aren't allowing a default C to be added. You have to use whatever random seed you get. So this will add a bit of complexity to any testing. All right. So that returns a double. Then what we're going to do is we're going to create a set. So we need to include set. Sorry, I have a note here saying I need the standard exception library, and I'm not seeing why oh, I know why I need it. We're not going to actually probably need it for a while. All right, so for this one, what we're going to do is another inline, and so we're going to turn a set of integers. And this is going to be get random distinct numbers. Now, the great part about set is the numbers are always distinct. So returns amount of numbers from 0 to upper limit. Actually, from 0 to upper limit. So we need 2 arguments for this one. We need an int called upper limit in. Also, I'm just gonna make sure that this is called in. There we go. Just want to keep my convention of using the word in around so it's easier to follow through. So we have our upper limit, and then we have an int that will be our amount in. So the amount of numbers we're generating. So we're going to declare a set, and this will be set int, and this will be a generated numbers. Sorry, I didn't mean to say a generated numbers. This will be an empty set called generated numbers, and then we'll iterate through the set. So we'll do while generated numbers size is less than amount, and then we will add a number in. In fact, actually, you know, because we are going to have lines underneath this. So we're going to take generated amount in. There we go. Generated numbers. And we're going to do insert s random very fast. So remember, we're getting an integer, so this doesn't have an upper limit. It's the, well, it has a max upper limit. And then we're going to use our upper limit in. And yay for that E key issue. And then we're going to return our generated numbers. Okay, there we go. So that's our random set done. All right, sorry, I'm just thinking about what I want to do next. We need 3 Boolean. Keep reaching for my empty water bottle. I gotta remember I put it over there. Memory is not my strong suit. Okay, that was wittier in my head. I promise that sounded wittier in my head. So pretend you're all sitting in my head and can hear how witty it was there. It doesn't work that way, does it? All right, so before I continue to make a fool of myself, let's return to coding. So we have our random pseudo number generators. We have our common functions, and now we're going to have our random bool function. So I'm just going to copy this note so I know what I'm looking at in my own code. And this function library will be used for random bools. So these functions generate random bools. That's literally, yeah. That last bit stays the same as well. Sorry, I was gonna fix that. That was driving me crazy. I saw that earlier when I was copying it. All right, so first what we're gonna do is we're gonna get a random bool with a 50% chance of being 50% chance of either true or false. So we're going to use overload. We're going to overload our operator here, or our function here, our method. So it'll be bool get rand bool. This version of it will have no arguments. At least sitting in your head, there'd be legroom. Yeah, it is pretty hollow in there. It really is. I mean, sometime during my doctorate, I lost my the thing that goes in here. I can't remember what it's called. There's a reason why this channel is known as 2 neurons. Seriously. That wasn't... This is actually the legitimate reason the channel is known as 2 neurons. I only have 2 neurons to rub together. Alright, I will show myself out after that one. Anyway, what we're going to do is get a random number. So we're going to do double, and then it's going to call this rn for random number, random double. Hey, look. Like I said, we're using this in other math utilities. So we're getting a random double here. And we know this is going to be between 0 and 1.111. Or sorry, 1.111. 0.999. Seriously, like I said, the thing in here, which I can't remember the name of, is missing. All right, and what we want to do is check if Rn, our random number, is less than 0.5. If it is less than 0.5, then we return true. I'm not sure what I'm trying to do here, but I'm just going to do return true. Boom. Otherwise, I'm going to put the else in. Else, return false. We don't actually need the else. It could just have done the brackets and drop down and done an else. All right, next what we're going to do is get a random bool with user inputted chance. So instead of defaulting out to 50%, we're going to let the user determine the chance if it's true or false. So what we'll do first is we'll do inline bool. We'll do get random bool, and then we'll overload it by including an argument called probability in. I'm about to start driving. We'll be listening up until I get my kid. Hope you have a great night. Thank you very much, Chica, for being here. Hope you have a good weekend with your kid. Don't do anything that I wouldn't do. Don't do anything I definitely would do either. This is a very, very, like, weird line that you should walk down. All right, so what we'll do here is we're going to check that the probability that's inputted is a valid probability within an acceptable range. Remember, probabilities range 0 to 1. So we're actually going to... There's a few ways we could tackle this. We could have it crash out, throw an error, have it just go, nope, you've put an invalid number in, bye. We could have it reset and cap the value to the correct amount. We could have a combination of the two. So we're going to just pause on that part of this method for a moment. So this is checks range. And we're going to talk about what happens when we know that it's good. Well, we're going to do a double called Rn, and it being the probability. And this will be called random double. Or we're going to get this from random double. That will be called random double. We're using our function random double. We'll do if, and then we're going to check is Rn less than our probability in. If it is, then we're going to return true. So the way to think about this is that if we input the value of 0.7, so we do get random bool 0.7, it checks if it gives a 70% chance that there will be a true. So it would only be, so you have 0 to 0.69. If it returns a value in that range, it's true, 70%. From 70 to 0.99, so another 30%. If it's in that range, it's false. All right, so we're going to return true. Else, we return false. Hey, look, it's the same thing we did up here. So what we need to do for this check range bit, I haven't decided while rambling. I was literally trying to ramble at you to think about what I wanted to do with my check range thing. So, I know what I'm going to do. I know what I want to do. That will take us a bit to... Give me a second. We're going to go to our properties for a moment. Oh, I didn't want those properties. I wanted the properties for this bit. Or apparently these are the same. Where is the thing I'm looking for? Am I just blind? Oh, Haynes, Anas, sorry. I planned to do this for a while. I just didn't plan when I'd be doing this. And don't worry, I'll be working on your stuff later tonight too. Just not on here. Sorry, I'm trying to find... I want to use something that Microsoft does not like, and it freaks out. And I can never remember where it's stored. It would not be linker is the most obvious spot for it to be. No, it's not a dependency. Might be under my debug, and I just might not be seeing it. Give me 1 second. I'm trying to find the name of the thing I want to use. Oh my god, what's it called? It's for ignoring particular errors, because I want to actually turn this into a DLL down the road. Oh, it's the CRT Secure No Warnings one. So I can't remember where the heck I want to put that. So hey, here's our machine learning thing from earlier. I'm just going to paste that into Google. I looked this up earlier, clearly. And hey, there's a lovely image. Let's take a look at it. Oh, configuration properties. Dude, I am in the right thing. Configuration properties. Yeah. Where is... Okay. Because I don't have any... Yeah, okay. Never mind. I know why it's not working. If someone's already posted in the chat, yeah, I know exactly why it's not doing what I want it to do. That's A-okay. That is perfectly fine. Okay, so what I'm going to do to explain, I want to use an fopen. An fopen is not liked by Microsoft, but if you want to be a bit agnostic, creating a DLL, then yeah, that's useful. So what we'll do is I'm just trying to figure out where I want to create this at. Right, I think what I'm going to do is I'm going to create a new header here. Give me 1 second before I do this, actually. I'm going to create a new header. Actually, I'm going to create a new class file. Actually, you know, this might not be, this might just might be a header. This might just be an interface file. No, we will do this. We'll do this as a proper class instead. But this will be called Debug Utils. Okay. So in Debug Utils, what we need to do is we're gonna need access to fprint. So fprint is in the studio. So we're doing this for fprint. Do we need the standard library? I don't think so. What's weird is sometimes I need to use the standard int library to get uint32, and I just realized in here I didn't. I mean, we do have CMath, so that might be why. But yeah. Okay. So yeah, there's that. What we'll do is we'll create a namespace. So namespace, and this will be udebug. I just want to see. Yeah, I'm not going to need to create another argument for this. Okay, so it's udebug. And then we will do a class in here instead. Actually, no, we'll just do the namespace, and we'll then create... Yeah, we're going to do the namespace, and then we're going to do void yeah, we'll just do void debug log. And then what we'll do here is we'll do one with no argument. We'll do some with arguments. No, they're all going to need arguments. So we're going to include the string library as well. And this will be std string input in. Okay. Let's go ahead and then create a... We're going to cheat a bit. We're going to refactor. It'll create the class file for us. There we go. We're going to move the class file there. We'll pop open to class file. We'll need to do include. And then we're going to go back to, and for our, the direction of our strokes actually matters. And I'm just trying to remember what the direction you want to use if you plan to be cross-platform is. And I'm blanking on it. I am genuinely blanking on it. If you remember what the directions should be for that, please remind me, because holy crap, my brain is pulling I can't remember anything on me right now. I think it's that slash. I think. All right, so what we're gonna do is go from here into our headers folder. I don't like when I don't have IntelliSense, guiding me. Utilities, not headers. Oh, we need to go up yet another folder. Includes utilities, and now we want the debug. Okay. And now we can go into here and create our definition. There you go. Notice it's updated there. We pop over here. You can see it's updated. Okay, so ooh, I just realized there's a problem. Okay. Well, one thing at a time. First, let's deal with writing to this file. Then we'll deal with the problem I just realized that I've accidentally created for myself. Yeah. So what we need to do is create a file pointer that will be used for storing. We're going to write to where we're storing. So we're going to create file pointer type. We're just going to call this file. And then we are going to do file equals fopen. And then the file name. And in this case, we're going to use the name we're going to use the name logs debug.text. And this will be of type write. Just really want to build really quickly and see what failed, because I know I did something wrong there. Oh, yeah, dang it. That's the thing I was looking to resolve earlier. There we go. That's what I wanted. Preprocessor. And now just going to go back and grab that line that I want to include, which is CRT, secure, no warnings. And we're just going to drop that in the start of this. There we go. Save it. Build. Why are we failing? I just literally did that. Oh, it should be capitalized. Whoops. Okay, let's pop this back open. We're going to edit, and this is underscore CRT underscore secure no underscore warnings. Okay, apply. Now build. Ooh. Unresolved external main referenced. Oh. Add new item. Should have done this at the start. By the way, that's bad practice what I did not doing this. Okay. So int main return 0. And this is include IO stream. And this would say std cout hello world. Okay. Also to be proper. Okay. Sorry, it was freaking out at me because I haven't set this to be a library yet, so it actually is expecting a main, and it's like, there's nothing there to compile. What do you want from me? Why? Why are you doing this to me? So, yeah, sorry about that. By the way, my chair is sliding down the longer I do the stream for. By the way, I have no idea how long I've been live, so, yeah. I need a new desk chair, by the way. So what we're going to do here, not in main, in our Debug Util, is first we're going to actually check, do we have one of these things yet? If not, we're going to write one. So we're going to have 3 functions for this bit. But first we're going to do the actual writing of the debug log of going, hey, you've done this mistake. So, actually I'm going to rename this. It should be, actually no, debug log is fine. No, write to debug log. Okay. There we go. So we're going to make sure that the file is valid. So if, why did I put brackets? If file, all we're going to do there is we're going to set date and time, print, set message stroke log. So what we're going to do is we're going to do print f, and it will be well, first let's get the string in there. So that'll be string, and then we'll do new line, and then this will be input in. I forgot the comma. Okay. Just want to make sure I can convert for string. Object parsed as param2 when a string is required in call print f. Actual class basic string tar struct. Honestly, as long as it works, I don't care if that part's efficient or not. I really at this stage don't. So we're going to print whatever the message is, and we'll set our messages for that. Now, what we need to do is get the date and time. So, yeah. And I'm just looking at my printf stuff real quick. Sorry, give me 1 second. I'm going to bring it over here so you can see what I'm doing. And yes, I realize it's from the C stuff, so I just want to... What are I doing? Date and time. Okay, so we'll need to check... we'll need to include in our debugs util the C times, time singular, not times. It's not a newspaper, folks. No siree, it is not a newspaper. All right, so we have printf, which we're getting from the C library, from that. Sorry, I need to find where I put this. Thank you. Pretty sure, hang on. TM struct time C. Pretty sure, yeah. Oh, wait, no, that doesn't tell me. Useful. Let's go here. That's what I'm looking for. Okay, so they're all type ints. That's what I couldn't remember. I'm like, are they ints? Are they something else? So it's ints. All right. So what we will do is we will do fprintf. I think it's fprintf. And I'm just now double checking what I'm doing because I've... Oh, this should be fprintf. This should not be, in both cases, I'm pretty sure this should be fprintf and not printf. I think I just went off on chasing off... sorry about that. That was my GitHub for something else. Chasing off on random things that weren't right. Because I wasn't thinking. So it's fprintf I want, first off, because we're printing it somewhere, and I haven't said where we're printing it to. File. Oh. File. And then we're just going to leave that for a second. No. Okay. I'm glad I double checked and it wasn't going crazy. Hey, Derek Kidden. I am just coding out a new neural network. We're doing the utilities first, just so I have access to all the things I'm going to call up later on. And then we're going to switch over partway through this to writing out a, well, not an entire today at least. Starting to work on building a engine for games, or game engine. I forgot the words clearly. I'm having a special moment today. Apparently I'm also missing my water again. Okay. How are you doing, by the way? Ow. If you didn't hear that thud, that was my fist and the water bottle both hitting the desk at the same time. Ow. Okay, so we're printing to the file name. What we're going to print is an integer. Hang on, I just want to think about the order in which I'm going to do this. You know what, instead of saying it out loud, what we're going to do, year, month, date, YMD, space, H, MS. Okay. Sorry, it took me a minute to work out how I wanted this to actually show up. And so it is, and let me get the little table back up because I so rarely use printf. It's not. Okay, that's fairly easy. It's literally just going to be f for everything. Though it's decimal, I realize. So we probably actually want, we don't want fprint, we want print C library. Oh, I love forgetting. This is printf. I think I only hit printf. Okay, cool. So we will use, yeah, we'll do f space f. Okay, let's write out what these f's are now. So for this, we need the C time, which I think I've included in the header. Yep, that's what I did a few minutes ago before I got distracted by trying to figure out what the structure was actually made of. And I'm just gonna get the structure back on my other screen. Sorry, I moved the window I had opened up that had the int stuff over to the other window. So, you know what? Give me a second. We're actually going to do this completely differently. Just give me 1 second. So what we're going to do instead is we're going to do std time t now is equal to time 0 and by the way, how's it going with the UE5 version of the Survival series, Dark Kitten? But time now. We are then, so current date time based on current system. We want to convert this to a string, so we're going to do char pointer because we're using the C library for what we're doing. So we're going to do date time as C time, and we want to pass in the reference to the variable we just created. That was not what I meant to do. That's what I meant to do. Sorry about that. Okay. And then we are going to pass that string of characters out in this fprint f I was doing down here. Okay. The format no longer matters. We're getting whatever's returned to us this way. And this is literally going to be, and it shouldn't have been a new line. C. No, not C, it's S. So literally right there. Oh my god. S. And we're going to do that. And then this will be DT. There we go. And it's going good. They fixed the UI you told me about. See, I haven't had that worked. I didn't even mean to have the F, so I'm glad I got rid of them. The C library is such a weird thing to me. I'm so used to using cout, things like that, but because a lot of the C++ stuff for it by the way, yes, I do have a monster and water, is at least when you're using Visual Studio, is bound to Microsoft's stuff. Actually, no, not Visual Studio, because it's standard now. They made the standard. I'm so used to using their stuff, the standard library, that the C library just throws me for a loop every so often. It's really funny, like, the basic stuff in the C library, I'm sitting there going, I can't remember how to do the basic C library. I can remember how to do the C++ library, but the basic C? Nope. Nada. All right. Okay, so there are several things I want to do with this, and I'm just trying to figure out the order I want to tackle them in. Okay, so let me just make a note here for one of them. Let me make a note. No, let me make a note here first. Throw exception. Else. So I'm going to have a different sort of debug error. If for some reason I can't write the debug file. All right. No, I'm not. No, ignore what I just said. Because if I do that, then I am locking myself into a different choice at the start of this function. That entire thing can be combined into one approach. So we are going to try to open this file. If we fail to open, we're going to try to write to this file. No, I remember why. We need to try to see if the file exists first. All right, so I know I haven't closed it. I'll deal with the closing the file in a moment. We need to see, has this file been written first? Does it exist, or do we need to create one? So what we're going to do is first, we're going to go back here. We are going to think about this for like a good second here. You know, I've never tried to do what I'm thinking about, and I'm going to Google this one because I legitimately don't know. Can you use... Sorry, because it might be a really obvious thing and I don't know the answer, I am not reading out what I just Googled. Yes, you can. You can't do it the way I thought you could, though. Oh, but that won't work. Okay. So what I'm trying to figure out how to do is I want to create a constant variable, but I want it to... You know what? If I actually intend to make this into a DLL, to make it into a proper library or module file, then I can just block access to this in other ways. And if you really want to screw yourself by doing that, okay, go for it. However, just give me 1 second. It is const char pointer. Okay, so we're going to actually create a variable, const char, and this will be pname debug log. And we will give this a default value. In fact, I'm going to come back here. I'm going to steal that bit. Paste that into there. There we go. Okay, now that we have that, I'm going to then take this and get rid of that. There we go. Okay. So what we needed to have then is bool check debug log. Okay. Sorry. I skipped actually, telling it to do that because I'm being lazy and not copying and pasting. All right. So we're going to check the debug log. So what we do here is we're going to do, give me 1 second. I just want to see if there is an operator for fopen, fopen that I'm not remembering. Fopen, C. We're just going to do R. Oh, wait, hang on. Creates an empty file if a file with the same name already exists. Oh, crap. I'm glad I did that. I didn't mean to do W here. What I meant to do is A, and I'm just making sure it's not A plus I need. So A is append. Append is open file for output at the end of a file. Output operations always write the data at the end of the file, expanding it. So we want A here. A file is created if it does not exist, so we don't need this. Cool. That actually makes our life easier. I'm still going to leave that in here because I might want this elsewhere. So if the file does not exist, it will create one. Okay. So that's fairly simple. So if the file is not valid, then, so we're going to do an else now. And we will need the standard except library for this bit. And yes, I am putting them in the header because I do want access to them there, and I will probably use them for other things as well. So what we're going to do is throw a runtime error. And just let them know, hey, your local log system ain't working. But yeah, so we want to do a runtime error. And I'm just trying to think. Yeah, no, we'll just do a runtime error. So throw runtime error, and we're gonna just have this spit out input or debug log error could not find or create debug log. And in addition to this, what we'll do is a print f. Also, at the end of this, we're going to do exit 1. All right, so we'll do print f. And what this one will say is, it will say failed to locate debug log. Actually, we don't want to exit. We're still going to have the runtime error. We can ignore it. We'll deal with how to handle. We'll update the runtime errors later. Failed to locate debug log, and failed to locate, failed to read or write. All right, debug log. Okay, so we're getting that message in 2 spots for now. All right, so write to debug log, failed to write to debug log. Okay, so let's go back here to our Math Utils, and we were doing that so we could write out, hey, dumb butt person who has put the wrong values in, this isn't going to work the way you think it's going to. So what we need to do here is we need to include, and then we're going to do, and yes, we're doing this in the implementation file. sorry, this is only a header file. So yes, we're doing it in the header and stroke implementation file. We need to include debug seriously, you're in the same folder. Oh, debug, there we go. Having a moment there, clearly. I'm not sure what sort of moment that was, besides embarrassing for me. And what we're going to do here is, it should be udebug. And then we want write to log. Is there a way to block it? I'll deal with that later. Write to log. Okay. Text. Okay, so checks range. What we're going to do is we're going to actually have a 3-part if statement. So if probability in is greater than 1, what we're going to do in this case, oh, sorry, let's write these all out. If, else if probability in is less than 0. And then finally, else if probability in is equal to, actually, you know what? No, we're going to do it as a 2-part. We'll do this as greater than or equal to 1. All right, let's cut this, paste this here. The text will be out of range, or okay, so here, maths utils. Type get random bool double probability in probability out of range greater equal to 1. Reset probability, reset output or returned false. All right, so what we're going to do is we're going to actually return out of here. We're going to, because we're saying what here is we're going to say the probability is, actually no, this would be returned true. So remember my example earlier, if we do get, so bool b equals get random bool 0.7. It checks if 0.7 is in range. It is. It gets a double, 0 to 0.99. If it is less than that value, our random number, then it's going to be acceptable. Anything that's 1 or greater than 1 is always going to be true. So we're going to just return true. In this case, we're going to do the same thing, except for we're going to return false. And we are going to say less than 0. And it's returned false. Okay. There we go. And then we'll do this as the else. There we go. So this is what we really want to have happen, this else here, but we have a catch if people have done the wrong things. Sorry that took me so long to actually write this out. Like, I was sitting there making changes to the design while I was thinking about it, and thus we had the randomness there of me going, well, now I need to write this other thing I didn't expect to write. Like I said, these videos are going to be a bit different. I'm not going to have a format to them, so we are just going to go with the flow in terms of whatever I need to figure out to put into this. And yes, some things won't be optimized because, oh my god, this it just already hurts me a little bit. And there's only one function in there. All right. And then finally, we're going to do a third get random bool, which pretty much is the same as the second one we just did, except for this one gets a random bool with user inputted ratio. So we're going to use our ratio function from up here that we just created. And so again, we're going to do inline bool get random bool, so EA for overloading. And what we're going to do here is float raw value in, float minimum in, float maximum in. All right, really quickly, just give me 1 second because I didn't keep to my convention up here. All right, so let me just find all my raw values and change it over to this. Fix that up. And then this one. And a quick build. There be no issues, yo. We move on to this bit. And in here, what we do is we are going to do double probability is equal to get ratio. Sorry, not get random bool. Get ratio. Raw value in, minimum in, maximum in. And then we are going to get a double RN, and then we're going to do a random double, just like the other two functions. And we're going to check if RN is less than our probability. If it is, then we return true. Now, no, this won't. Yeah, no, that will always return true. Else, it's going to return false. And because we really don't need the brackets for this one, these are single line commands. Let's just clean it up. There we go. Okay, so there is our last get random bool. Okay, sorry how long that took getting through the setup of this. And now I just need to check how long I've been doing this for, doing the setup. It doesn't say. Oh, that is not useful, YouTube. Over an hour. Okay. Of course, over 2 hours. Of course, there was also the 10 minutes where there was no sound, and then the, 7-minute break I took. All right. So we're going to write three class files. I just noticed that the main is in my utilities folder. Yeah, you get to be can you be in your own thing? Okay. That's what I wanted. It was right the first time. I just misread that as it will be deleted, not it will be moved. So we're going to create 3 files. Now, let me just collapse these down so I can think about the structure for just a couple of seconds here. So I want to have a I want another utility. That's not going to be a folder. All right, so I'm going to have a Neuron class. I'm going to have a layer class, which will have children. I'm going to have a network class, which might have children. So I'm going to create a neural net folder. Yeah, I'm just going to, I might overfolder it. Sorry if I do. We'll call this neural network. And in here we're going to have another folder called neuron. And then go up one, another folder called controller. That's our network controller. And then actually, you know what? Rename this as network. Controller is something else. Sorry, we will probably end up in one of these videos putting an actual controller in as well. And then we're going to have a layers folder. All right, I want to copy these, replicate them in my includes. Okay. So I am just thinking, hey, Bang Bang, long time no see. How have you been, man? So sorry, in my head, I'm parsing out the parts of a neural network, and I'm not sure how to describe what I'm thinking about. But basically, what I'm sitting here doing, wishing that whiteboard over there was like on a wall, and I could actually use the eraser on it and write on it and all that fun stuff. What I'm trying to do is I'm parsing out in my head if I want an interface or not to communicate between these. Now, I'm thinking about this in terms of simple OOP and in terms of efficiency. Terms of OOP, our network, are those three parts: the layer, the neuron, and the network itself. So remember, the neurons make up a layer, multiple types of layers, or a layer, because you do have a single hop-field layer network. Sorry, a single layer network, like a hop-field network. And the network architecture, which is the network itself, all are related to each other. They all should really kind of be talking to each other, but when we want to have boundaries to that. So I'm arguing in my head, should I be using friend of class approach? Should I be using interfaces, or should they be inheriting from a class above them? And as I'm thinking about this, that last option I've seen people do. I'm actually toying with that for a series I'm writing. So if you know that I'm writing a machine learning series, that's actually the first approach we use in that series. And I really don't like that approach personally. It's actually great for teaching. Like, don't get me wrong, it's great for teaching. But I think for like the things I have done, the coding I've worked on, it raises problems for me. Bang Bang, I have big question. How does the new retarget system work? So I had problems recently. I can't use Unreal 5. I've not used the new retargeting system, so I can't answer that. I am going to turn my camera off for a second because I'm going to do something that I should not be doing in my house. Again, don't do what I'm doing. It's bad. It's not healthy. If you don't know what I'm doing, by the way, it's a thing I took a break for a little bit ago. That is to say, cigarette. So, yeah, I think what we'll start with is the neuron itself. Because that gives me a bit of room to think about things. And yeah, we'll start with the neuron itself. So let's go here, add new item, header. This will be the neuron master, because I'm not sure if I'll have any children, or the neuron parent. Okay, so I'm just gonna go in here. This is clearly not a math function utility library. This is neuron class declaration. So what this class is, as I delete those lines that I accidentally just didn't need to delete or could have written over, this class file, really? Class file is the Neuron class, which will be put into a vector as part of a neuron layer. Okay. So the neurons will be polymorphic in that they'll be able to receive an input outside source or from another neuron. So we're polymorphic in nature. And the neuron will see. So we're polymorphic in nature. And evaluation is made, determined by settings in the network. This evaluation then, so this is weight, this is input, as an example, weight bias. The data, or the evaluated input, or transformed input. So a transformation is made. The transformed value is passed through an activation function. And that's actually the setting that's determined by the network. From there, the neuron, or neuron, if you prefer, passes the information out. So output final decision stroke value to user, or output value to next neuron. Right. Hopefully that was clear. If not, well, I will try to make it clear as we go. All right, so this is a class. So we're going to do class neuron. Right, let me just cheat and get my little Excel thing open. Yes, I really do the things. This is actually for my Unreal stuff, but I like having my setup this way. It just makes it easier for me to find things. I get my conventions might not be for everyone, but hey. Right. So for our constructors, we're going to have our default constructor. So let's do that one really quickly. First, let's put this in the public scope. Otherwise, we're going to have issues. And our default constructor, you should all know how to do. Also, I finished that cigarette, so here we go. So our default constructor you should know how to do, and that's just going to be the name of the class. And then we have our destructor. And it's actually going to be virtual, so we can override it if we need to. And it'll be neuron again. This is hard. This is basic stuff, constructors and destructors. What comes next, that might be a different thing. Okay. So, I'm going to want to include vector. Right. So, now that we've done that, we can get our attributes. Sometimes it lets the controls that thing work correctly. Sometimes it doesn't. So this is going to be private. So input into a particular neuron. Vector will be unsized resized when called. So what we're going to have here is std vector double input values. We aren't going to set it. And then we're going to have the number of inputs, the length of the input values vector. If 0, the neuron instance will not initialize. The default is 0. So int, actually let's use uint 32t, number of inputs. We'll default it out to 0. Yeah, some things are easier in Blueprint, some things are easier in C++. It depends on what you're doing. All right, because that's private, I'm very quickly going to create 2 functions. I'm just going to grab these 3 bits. You know what? These I actually like having left flush. I forgot about that. And that's because of what I do in the method section. There we go. All right, so we're going to have public. And this is, first one we're going to have is set number of inputs. Also, this should have a type. And this will be, actually, no, this is public, not protected. This will be type void. It's going to take 1 argument of uint32, and that's going to be num of inputs in. Okay, and then we're going to have a getter of uint32 get number of inputs, and we're going to do this as an inline const, and we're going to return our number of inputs. And we're just going to build real quick, make sure. I'm going to have 1 error. Oh, wow, it actually didn't error out. Okay. Okay. Not sure why I didn't get that error, but let's very quickly create a class file. There we go. And let's move that into Neuron. Now let's create it properly. Oh, I can't see it still, because we need to go into here and do include, and then we're going to go back 2 folders. And we want 3 folders. That's not what I said to do, but okay. Then we want our includes. We want neural network. Sorry, I just saw an issue and I'm going to fix that up in a minute. And then there we go. All right, let's delete that folder. Right, now let's go back here. I wonder if C++ is mandatory to create a game, or I could continue to just use Blueprint. You can do games purely in C++, purely in Blueprint if you wanted. It is entirely possible. There are games that have done it. So it is not something that is not unreasonable. All right, so what we're going to do here is num of inputs is equal to num of inputs in. Sorry, this would be set. There we go. Okay. And then we'll also take our input values, and then we're going to resize it to number of inputs. Okay. There we go. All right. So next we're going to have the output for the neuron. So this will be output from this instance of the neuron. This value will be added as an input to the above vector in the next layer. So into the number of inputs and the input values. All right, so what this is, it's going to be double output and then we're going to have output from this neuron prior to activation function. So i.e. input times weight plus bias. Actually, I should say EG because we might not have a bias. Okay, so what this is a double, and it's output before activation. And we'll default this out to 0 as well. There we go. All right. I'm just trying to think about the activation function, how I want to tackle the settings for that. I know it's going to be an enum. I'm not sure where I'm going to actually, how I'm going to handle that. So we're going to move on from that for a second. And then we're going to do weights associated with this neuron. Okay, so that's going to be another vector. And it's going to be a vector of doubles, which we'll call weights. And I'm going to think about how I'm going to resize this later on, but we'll talk about that in a minute. And then we have our bias. And we're going to just default bias out to 0 for now. Okay. So we really need to think about how we're going to do the activation function, how we're going to set it. I know what we're going to do. We're going to create an enum class. See you later, Bang Bang Man. Have a good day. So what we'll do is we'll create an enum that will have our activation functions in them. We're going to start with the simple ones like sigmoid, hard limiting, linear, those very, very simple ones. So for that, we'll say in the includes. We'll create a new folder for this actually called enums. Or also delete the random extra folders it gave us. Okay, so in enums, what we'll do is we'll create a new header. And call this network settings. Sorry, I had to think of a name for this. And what we're going to do here, so just so we have settings, enums, a collection of enums, AB structs that are used for neural network settings. Okay. So first thing we're going to do is enum class activation method. And our methods will be step, linear, sigmoid, hypertan. Hang on. We're going to go to Wikipedia. Common activation functions. I want the Wikipedia article. Thank you. So step is our hard limiting, otherwise known as a binary step. We have our logistic, which is our sigmoid. We have our identity, which is our linear. And we have our hyperbolic tangent, which is the tan. Yep, those are the the four first ones on the Wikipedia article are the four most common. I just want to make sure I had all of them. So the names might be a little bit different. Like I said, binary step is sometimes known as a hard limiting. Identity and linear are the same. Then we have logistic, sigmoid, or soft step. And then we have hypertan or tan. So there we go. All right. With that done, what I'm going to do is I'm going to pop over to back over to my Neuron header master here. And under my private functions here, actually, no, sorry. First, we're going to go up here. We're going to do include. And then we're going to go back, what was it, 3 folders? Oh, so we're in the header, so we only need to go back 2. We need to go into enums, and then we need our network settings. And then what we'll do is we will come down to here, and this will be the activation method. All right, and we'll actually probably add our activation methods into our math utils file. So what we'll do here though is activation method selection, and then we'll default this out to activation method sigmoid. So we'll just default to sigmoid. So default linear, sorry, not linear. Yeah, linear. Sorry, I'm trying to get back to the window, and I know I closed it. So let me just do this. Yeah, it's linear. It's logistic. Oh, it's not linear. Identity is linear. This is logistic. Yeah. All right. Default is sigmoid. Right. Okay. So there is our activation. And I will just comment this out really quickly as sets number of inputs to this instance of the neuron. Then we'll have sets the activation method for this neuron, and that will be void set activation method. And let me fix the typo on that, and that will be activation method. And I'll be called method in. Okay. So and all we're doing here is we'll take the selection and we set that to method in. There we go. Okay. So we need to build the neuron. We need to do the initial transform. We need to do the activation, which we'll probably again do in the math utilities and just return it in here. And we need to update our weights, set individual weights, set individual inputs. Also, while we're thinking about it, let's comment this out. We just did the set activation method. We'll return the activation method as well. So this returns the number of inputs to a neuron. All right, and this returns the activation method of this neuron. Why is neuron capital in some of these and not in others? Because I'm used to doing my name. Inline, and this is activation method get activation method, and it's const return, and then we're returning activation, or what did I call it? Selection. You know what? We're actually going to rename this as activation method. And actually, I will do that as activation method. And it should be in the neuron header twice and once in the C++ file. So we'll hit apply. There are the changes. I'm missing a semicolon there. It was correct there. And it's correct there. Let me just quickly rebuild, make sure that it doesn't throw me an error because that's a very similar name, but that lowercase e should prevent any fun issues. Right, what we're gonna do next is, now that we have our activation method set, we can get that activation method. We need to think about, again, building the neuron and the all the settings we have to do. So for building the neuron, just trying to think about everything we need. We need to do the weights. We need to do right. I'm just gonna cheat a bit. I'm gonna go to here into the actual the implementation file. First, I skipped really important ones. You know, the constructor and the destructor. Okay, there we go. All right, so void neuron I just realized that the class name and the whatever neuron build neuron. All right. So when we build the neuron, we need to adjust our, okay, first we're gonna just, for now, set our bias to be 1.0. All right, just so I have access to things and don't have to panic when I'm seeing errors. We're gonna send a post that there for now. Get rid of the scope there. All right, cool. I'm gonna use the one I want to use. Oh yeah, I can't. I've already defined you. Yeah. Or declared you. All right, so we're going to initialize bias to 1 just for now. We will do if number of inputs is greater than 0. We will actually only do this if the inputs are greater than 0. Okay, so if it is greater than 0, we want to set the bias. We then want to do weights.resize, and we're going to resize them to the number of inputs plus 1. We are then going to go to weights. We are going to clear anything there. So remove garbage, allocate space for weights in memory, and set bias. We'll change this later. Okay, so there we go. It's actually fairly simple. All right, so then after that, what we need to do is we need to initialize the neuron. So you know what? Actually, what we're going to do is we're going to update this a bit. We're going to get rid of this. We're going to get rid of that. We're going to get rid of that. Okay. So instead what we're going to do is we're going to come in and I'll think about the condition check later on. What we're going to do is we are going to do set number of inputs. We're going to pass that in. Sorry. We're going to pass not the uint part of that in. There we go. We're going to pass that in. So we're going to set the number of inputs. And we're actually going to come back into here. And we are going to change this bit to sorry, input. I just realized there's a couple other changes I'm thinking about as I'm doing this. And that will just remove any garbage from there. No, the clear has to be before. Otherwise, we end up with weirdness. I could use calc, I guess. If I really felt like it, I could just use calc and deal with it that way and then deal with the garbage collection down the road, but I'm going to avoid that. Okay. We're going to come in here and we're going to do sets number or sets weight vector up for further use. And in this case, what we're going to do here is we're going to do void set number or set weight vector. And we don't need any arguments at this point because all the information is actually stored elsewhere already. We're going to come into here. There we go. And actually, I do want this right up here. There we go. And what we're going to do is we're going to take this code here, and we're going to pass it down here. Now, this will work because we set this earlier. So as long as we call this set weight vector after we have called our set number of inputs, this will work correctly. Okay, there we go. Let's pop back over to here. Why do I have, oh, network settings. So that's a network control. I'm pretty sure I haven't started working on that yet. So we have our set weight vector. And you know what? We're also going to call our activation method here. Let's just copy all of this for now. Paste that there. And we're going to take this. We're going to copy it, put a comma here, delete this bit, delete that bit, go back to the header, put a comma here. There we go. Right. Let me put the semicolon that terminates that in there. So we've set our method. We have our input set. We've cleared it. We've resized it. We set our bias, which we'll update later. We've done our weights, which we clear. And we set based on the inputs, which we already set. We then set our activation method. Okay. So now we need to, so this sets primary default variables, or primary, not default, primary variables for the neuron. Right. So now that we've done that, what we're going to do is we're going to initialize the neuron. And to do that, we will create a new function, of course, called set, sorry, I guess I'll write the comment later. Void init neuron. This will take no arguments. And let's go ahead and just quickly define that. Pop back into here. And what we're going to do here is actually check is a number of inputs a valid one. So we're going to do if number of inputs is greater than 0. Because remember, if it's 0, we're not going to initialize it. So if 0, the neuron should fail out. All right. And this is to ensure that there are inputs. So we're really ensuring there is data. So ensure there is data to use or destroy this neuron. So what we're going to do is we're going to create a test line that I was thinking about how I wanted to do this, and we have to pass arguments in that we really don't need to worry about once it's done. So what we'll do is we'll do it here inside of the class file, write it with a debug line. So what we'll do is we'll write a line that says the next line is for debugging. If debugging, uncomment the line. Now, we're not going to have it commented right now, but what we are going to do is we are going to do include, and then we're going to go back a couple of folders, go into utilities, nope, sorry, this is the implementation file, we're not in a header, go back a couple other folders, include utilities, math utilities. Okay. So what we want to do is umath, and then we want to, sorry, hang on. What we're going to do is first off, let's do this in the correct function. So it's umath, and then it's not what I wanted to do still. Double new weight local. And in fact, actually, what I'm going to do is make this into a different function in just a second. Give me one moment. So it's set weight, and then sets random sets initial weights randomly, or sets random initial weights, and this will be void set init rand weights. All right, there we go. Let's now define this really quickly. Close that out, go back here, and we're gonna actually call that, above that comment there. We're gonna take this bit, we're gonna come into here, there we go. And what we'll do here is we are going to actually write this line twice. So it's going to be umath get very fast, and then we are going to pass in the value of 0 and the value of true, and we're going to leave it as is because it has the default max. We don't really care about that. The next line is for practical use if, and now I can do defines to do this, but for now I don't want to include any define stuff. If debugging, comment this line. And since we're currently going to be debugging, actually I'm not going to do it this way first. I'm going to grab it. We're going to paste this down here. We're going to delete the arguments. And we're going to just build it once. All right, where do we have the fail? What's going on with my debug util? All right, so what did I just do? I added this random very fast. So first time we're calling it, first time the system's seeing it. Hey, Hanas, how are you doing, man? So it's the first time it's seeing it. So let's go from here to our math util header. Let's go down to our random very fast. And why are you calling that? Result, shuffle table. I mean, the only one that should be calling that is this get random. Just for now, what we're gonna do, I just wanna see something. Okay, cool. So it wasn't that causing the issue. Already defined a neuron master. Char counts const u debug param. Oh, fuck. Okay. All right. Okay. Yeah, I forgot that happens. It's my include guard. I should have done it a different way. I can go back and clean it up at a different point. I'm just not going to spend the time digging through the settings to fix up what I want to do there. All right, so that compiled. Now we're going to reverse what's commented. And so long as it's compiling in both cases, I'm happy. We are going to leave it on the test method, so we know what the seed is, so we know that every time you run it, the first time it goes through, it will have the same values, so that we don't have to play guessing games of, is this value right? We're going to have expected values. We want convergence of information. If we're not getting convergence, well, we're going to be able to tell that more easily, and that's a problem. If we're getting convergence, we'll be able to tell it easily. That's wonderful. We can move on to the next step. But we need to be able to see it easily. So that's why we're including this 0 and override bit. Also, the reason why I have a bool check in there, and I recently read an article about that, is in case you accidentally put a number in there and you didn't mean to override the seed, it won't accidentally override it. It's actually a secondary check. You don't technically need it. Actually, you do need something to say, hey, actually, I have a value set. Don't, you know. Yeah. So we now have randomized our starting weights. And I actually don't like what I've done here. Sorry, I'm thinking about this. It's weights, plural. That's 1. Give me a second. I'm just thinking the math through in my head. So okay, that's why I'm confused. Sorry. This is technically wrong. We do need one more thing in there. So what we need to do before this is we need to do for size t I 0, I is less than the number of inputs, which we've already set, will increment I. All right, let's just move that in a line. And then what we're going to do is we're going to actually update these lines. This is now weights at index I is equal to we're gonna just very quickly write out one that's 0 up here. Put that in there, get rid of the double, boom. But no, we don't even need that. What am I doing? Okay, sorry about that. Clearly, I stopped thinking for a second there. And weights should be a double, so that should automatically put that into the correct type. If not, then we come back in and do the weights double thing. Okay, let's build really quickly, just make sure this still works. It succeeded. There we go. Wonderful. Okay. Something about this is bugging me, and I don't know what, but we'll work that out in a few, I guess. Okay, so now that we've done that, we initialized our weights and a random weights. Okay. So now that we've initialized our weights, we want to deal with our inputs and outputs, which I think we've already done. I mean, yeah, we did the inputs up there. Technically, we haven't set the actual values yet. So for that, what we're going to do is we are going to go into our neuron master, and now we need to go down a few lines. So this this will be updated later on because we're going to have non-random weight settings, and we're still going to use a init neuron. We'll use an enum in the settings to pass between which types we're doing sets initial values for weights and for bias. Okay. So we'll go down a couple lines because right now, if you think about it logically, all this is construction. What we're going to do next is actually, okay, I guess this is still construction, but the way I'm parsing it in my head is that now we're entering into the realm of we've built the network, we're putting data into the network, and we're moving data out of the network, or out of this neuron in particular. So what we're going to do is set inputs. So this is void. You know, I said this is virtual because we're going to override it. This is not virtual. Otherwise, everything else I'll be working on should be virtual. We'll come back to that when we get to the network settings. So this will be void set inputs. And what we'll do here is a pointer to a double called value. So we might change that to a vector, but we're going to do it that way for now. All right, so this will set the input values by taking the values being passed in. All right, so let's create this. Why are you giving me an error? Yes, it does. Okay, whatever. If you want to argue with me, computer, and then be wrong and I be right, then go for it, computer. Go for it. So what we're going to do for our set inputs here is we already have resized our input array up here. Sorry, I'm like hovering over the wrong line, I realize. Now what we're going to do is for size t, I is equal to 0. Yeah, I'm going to do it this way. Sorry, I was just thinking, I just have a potentially faster way of doing it without using a for loop, but I want to do it this way. I is less than num of inputs. Oh, well, I guess that might be part of the problem I'm having. Num of inputs. I will be iterated or incremented. Okay, just really quickly going to build to see that I'll still write. And then we're going to do input values at I is equal to values at I. Okay, let's build it real quick. Okay, so we're going to use an array into a vector, I realize, but we're doing that because we're going to have different read-in methods, and this should convert over nicely. Famous last words, I realize, so take that with a bit of, grain of salt. Okay, so we've now set our inputs. We want to start thinking about setting individual inputs, an individual, ooh. Okay, so let's go back to our header here, and we're actually going to go down to right under init random weights, and this is going to be set an individual weight value, and this will be void set individual weight, and we're going to do int I double, and then this will be value in. Okay, and we're going to create this really quickly. Whatever. Okay, so for this one, for set individual weight, what we will do is we are going to check if the index is valid. So we're going to do first if I is greater than or equal to 0, and I is less than the number of inputs plus 1. Actually, number of inputs. Sorry. It is this number of inputs. Then we will... we'll do a try. And before we continue with the try, we'll add our catch in. We'll fill in the argument for the catch in a moment. We'll do weights I equal value in. Also, really quickly, because I just realized I've not been keeping to one of my conventions. I realize the I doesn't keep to my convention. Not a big deal. Values in. Values in. Paste that down there. And from there, what we'll do is we will do a const std. And I think I'm going to need to include my... my std accept in here. And what we'll do is weights dot push back value in. So this is an attempt to resolve any out of scope issues. Actually, you know what? No, we're not going to do all of this. No. We're going to do weights, because if the value... that's not going to catch us out of range. Of the vector. It's going to catch if it's out of range of what we're doing. Which is fine. We want that. But it's not going to say if it's out of range of the vector. Oh, no, we are going to do it this way. So what we're doing first, we're checking is what we're putting in valid. Then we're going to check the range. Okay, so let me just comment this out so I get it right in my head. So check if in valid range of index for weights. Check that the range actually exists. And if it doesn't, then we're pushing it back to fit it in. Okay. Let me just build real quick. See what error I'm getting. Okay. No error. Cool. I'm still pretty certain I need the std accept, but I think I'm getting that out of the debugs right now, and the linker is being nice enough to me to go, hey, it's here. Don't worry about it. I got your back, bro. Right. So that is setting our individual weight. That's fine. That works. What we then want to do is set our individual input. So let's go back here. And we're going to do the same idea here with set an individual input value. And what we're going to do is just copy this, because the argument's the same, and it's instead of individual weight, it will be individual input. Okay. Let's just pop this open. Lovely. I mean, I could actually just copy that entire function, rename it, and it would be fine. Okay. All right. That's apparently what I'll be doing. Under set inputs, by the way, though. All right. There we go. Let's grab this chunk of code. Okay, so for set individual inputs, we're going to change this up, of course, because we're not changing weights here. We're going to be doing our input values. Right. And so I'm gonna just come back here for a second. I forgot throw, and I'm just gonna give it a value of 0, 0, 1. This will be throw 0, 0, 2. Oh yeah, I know about that. We're not so worried about that. Okay, so we're gonna change out, let's go back in here really quickly. Sorry, I'm just noticing little things. Int 32t. Int. Back in here, int. Int. Build. Give me 1 second. Apparently I forgot to actually deal with the error string I thought I was doing there. Okay, so for that, sorry, I'm just pulling up the C++ API for that just to make sure I'm not missing anything. Sorry, give me 1 second. Throw 0, 0, 1 equals weights. Throw 0, 0, 2 equals inputs. Okay. And what I'm going to do here is actually add in my debugs, include, and now that I'm doing this, oh my god, I really want to make this modular instead. Because then I wouldn't have to do all of this stuff. Nope. Includes utilities debugs. Okay. So let me just make sure I had this right. It's input string. Yep. Okay. What we're gonna do here is debug. Right to debug log. What we're gonna write there is so I'm just checking another function really quickly. I'm not sure if this is console or for printf or fprintf. Yeah, it's for console, so I don't want to use that. All right, so what I want to do is then do error string dot what. Yeah, I like that. Actually, you know what? String std string I don't want a C#. I want to make it sure that it's right in C++. Okay, so it's string. Actually, no, I don't want to do it in there. I can do it here. Error. Let's do this as out of range error. Sorry, I was just brain farting all over the place there for a moment. Okay. There we go. Right, sorry about that. That was painfully slow on my part, I realize. Okay, so before I got distracted by whatever that was, set individual weights. Set individual weights not found. Like, am I legitimately missing something? How aren't you seeing these two? Alright, I'm just going to assume it's an IntelliSense error and pray that it... Let me just clean this really quickly. Okay. Rebuild. Well, they got rid of that error for one of the two. So yeah, it is just some random error that we're dealing with. That's fine. What have you. Joy to the world, right? So, okay. So let's go back to our header. We're already in it. We've done individual weight. We've done individual input. Okay. I don't like how I'm organizing this. We're going to change this. It's going to be methods instead of setters, getters, what have you. We're going to do this in a completely different way. We're going to do this first as we're going to still keep setter and getter comments, actually. We're just going to duplicate this for a moment. And then we'll duplicate the getters in a moment as well. So first we're going to have... Actually, it'll still be setters and getters. Yep. I was right on that. This will be setup. Copy this for a moment. This will be... output. And then we'll have me clicking the wrong thing. Training. Stroke. Learning. Okay. So let's take these bits really quickly. Let's just paste them down here. Yeah, I know this really doesn't matter, but I'm just thinking about how I've organized things. Oops, that's not what I meant to do. I meant to do that. I'm actually going to change some things up. You're going down one more line. Like that. There we go. Okay. So these were the setup ones. Boink. Boink. Let's go down to our getters. These are related to setup. namespace. This is setup. There we go. Okay. So this is our output, including act and before act. Okay. There we go. We pass our inputs in as part of the start of doing our output, because that is, we're taking the data in that we need to work with. We are getting the values we need, and then we're making our decisions from there. Right. So next, what we're going to do is hopefully be a little bit more succinct. As I said at the start of this thing, it's a bit different than normal streams. So we have set output is the next one where we have to do. So what we do here is we're going to calculate the output values, and this is void set output. All right, and because I am morbidly curious. Hey, 109. So we should be towards the bottom. Actually, we should be the last one in there right now. Yep, 109. So set output. We have to consider, are we talking about the pre-activation output or the post-activation? Now, when we talk about the outputs, to go back to our header for a second here, we've declared this as singular in all cases. So I think we did it as plural down here. No, we did set output as singular. So again, that doesn't clear up if we're looking at the pre or post. So I was thinking it was plural because I was thinking of the layer, not the neuron. The layer gets the the layer gets the makes an amalgamation of all the outputs from the neurons within the layer. All right, so set output's actually going to take care of both. So what we're going to do is we're going to clear any junk out of the output before activation. So we're just going to set this back to 0. So we're clear junk from initial output value. Oh yeah, sorry, I just realized something. Give me 1 second. I think I skipped something earlier that said we were going to do, but never actually ended up doing. Yeah, that makes life so much wonderful, doesn't it? So we come in, we set the number of inputs. We set the number of inputs. Oh, sorry, hang on. We come in, we set the number of inputs, we set the vector, we set the bias too. We set the activation method, the number of inputs, and we initialize. Okay, no, I did not skip something, except for this. Else. Neuron. There we go. We're destroying ourselves. All right, sorry about that. I knew there was something I was missing. Now, the reason why we're doing that is just in case this fails out, like it did, just in case it fails out again. We're having some multiple checks in. So what we're going to do is then we're going to do another check. So we want to check that this neuron instance has been initialized early. That's all we're really doing. Could create a Boolean flag for that, and then we want to check if the input values are empty and if the weights are empty. Actually, what we're saying is we're checking they're not empty. So check that the instance has valid variables. All right. From there, what we're going to do is we're going to loop through our inputs and calculate our outputs. And there are different ways we can talk about this. We can do, for example, input plus or times weight plus bias. That's one of the most standard ones, right? Fairly simple approach to doing your input function. So, sorry, I'm scrolling through to find my list of input functions on my notes. And I closed my notes when I started the stream by accident and didn't. Or I have many note files open. I didn't scroll down to the right spot. So, what I'm looking for is my list of activation functions. Or, sorry, not activation functions. That's easy. What I'm looking for is my list of outputs before activation. All right, so what we're going to do for this approach is a little bit different. We're going to take the output. This is what we had to clear out before we did this, before activation. And what we have to remember, okay. We are taking in multiple values. So give me a second. I have a PowerPoint for this actually, because I'm planning on writing stuff for this. So let's go to the correct folder on my computer, please. Let's go to there. That's still the wrong folder. Slides. Wrong section. Slides. Nope, not the right one. This will work. Of course, it doesn't have the complex one I'm looking for. There we go. That's what I'm looking for. Okay, so what we're doing is we're thinking for a moment really about these two neurons in the center here, right? So these two are going to handle situations that are going to affect the middle bit here. It doesn't have to be two, by the way. It's going to handle every situation that will affect the layers and the neurons to the left and right. So basically, anything we write for the input or output layer, any layer in the middle is going to have replicas of those. But that said, the input layer and output layer are going to have different requirements of different things. There's no real input check here where we're summing weights in. There is for this, and there is for the output. For the output, there is no final putting everything together for the next layer. For the hidden layer and the middle layers, there is. For the input, there is. So, what we're doing here now, just as a heads up, is we're taking the values here, these three green or blue arrows leading into this gray neuron. we are taking them and we are summing them. And we are adding them into, we're taking the individual ones, we're multiplying it by the weight, adding in the bias. We are then taking all of those individual ones and summing them. So one approach we could do is sum of input weight bias. However, no matter what approach we use, it is always going to start with the sum. So to do that, what we do is we do a for loop. We're going to do for size ti 0, I is less than or equal to number of inputs, I plus plus. So we're going to iterate or increment through our I. And then we have the actual calculating of what the first half of our neuron looks like. So mathematically, what we're going to do for that bit is we are going to just double check what I'm thinking about in my head. Sorry, give me 1 second here. It doesn't seem right. I feel like bias needs to be updated. Biases. I think the biases might be wrong. That's how I set it up, that is. Okay, we'll worry about that later. I need to get through this to test it, and then we'll go back and fix it. So we're going to check, is I equal to the number of inputs? If it is, then we are going to use bias, which should be a capital B. If not, then we're going to do input values at I times weight at I. Sorry, that should be weights, I think. Yeah, weights. Okay. So another approach, and what we're doing here is sum. And I can't write this out properly, so I'm just going to do it this way. If I equals last neuron, bias is added in. Else, it is input times weight. Sorry, I'm looking right at it, and I had a problem. I'm like, wait, what am I looking at? Okay. So this is what we're actually doing. This is an example option. I'm just going to delete that line. So that's what we're attempting. That's keywords, attempting. We'll see if it actually works. That's what we're attempting to do here, then. So is the start of our neuron, right? Next, what we need to do is we need to actually get the actual output. So what we need to do is we need to send the output before activation through our activation function. Now, I'm pausing here for a moment to think if I'm going to put that in the neuron or in our math utilities. Personally, I'm inclined to put it in our math utilities, and that's what we'll do. However, I need to take a small bathroom break, so I'm going to pause. I'm just going to step away for a second. I'll see you in a few minutes. Seconds. Well, I'll see you in a minute. I be back. I'm gonna quickly look something up, completely unrelated to what I'm streaming. As you can see, I'm turning Spotify on. I realize I don't have music on in the background, so I'm gonna try to find some music that is appropriate for YouTube. I am so glad my camera's off because the hand gesture of me just waving in the air was, yeah. Give me 1 second. I would have loved if that actually had opened, you know, on Spotify instead of a website. Okay. Boink. Okay, let me just close that out. Go back to Spotify. Okay. And put desktop audio back on. There you go. And some background music while we're doing this that is truly copyright-free music for streamers. Okay. So, yeah. Let me know how the volume is for anyone who's still here, still watching, still dealing with me randomly minimizing the window that is the stream. Ooh, hello, ignore that. That was a resume builder for anyone curious. But yeah. So what we're going to do is write this into our math utilities file, as I said a little bit ago. And from there, what we'll do is we will then look at how we can, well, sorry, we're going to look at storing that information. Now, I'm going to quickly have a cigarette while I do this. So for this, what we're going to do is we have the activation method. So what we can do is we can switch on enum. So we can do switch. And then we can do our switch on. Sorry, let me hang on. Sorry, I want to get that macro to work right. And I like when that macro works right. So that's switch on E activation method. There we go. Okay. So we could actually pass this down to the math utilities, but I'd actually just rather do it here. So what we're going to do is calc actual output. Oh my god. Actual output post activation. This calcs output prior to activation, raw output. So this is our non-standardized data. This will be our standardized data. Okay, so our default will be sigmoid, so we'll just copy the sigmoid down here, by the way. For this, we will then have to write out the functions for each of these. So again, we can turn to Wikipedia for that. Wikipedia is also nice in having the activation functions there, both visually and with the mathematical representations that we would be using with them. So let's just go go over to our math utils. And I'm just going to collapse the things we're done with down again. Okay, so next we're going to have our activation functions. So So these functions generate the output for a neuron. The use case is literally in the line above it. So what we're going to do is we're going to have act step, which will take in one argument. All these will take in one argument, actually. Okay, so step is really easy. Step is also should be a double and inline. Okay, so what this is, we're going to do if x is less than 0, we return 0.0f, else return 1.0f. So again, if we go to Wikipedia, and I just closed it instead of keeping it open, activation function in neural networks, and go here, there is that formula. If it is 0, or if it is less than 0, then it's 0. If it's greater to or equal to 0, then it's 1. Okay, so that's the first one done. Next, we will do linear. So we'll do inline, double, act, linear, which would take the same argument. And what we're going to do here is we're going to do return a sorry, this is going to take 2 arguments. Double a double x. So a times x. So I'm just trying to figure out where I want to set a at really quickly. So what we're going to do here, we're actually going to set it in our neuron. And this will be our transform coefficient. And it's going to be of type double. Sorry, I am just double checking myself because, yeah, it's going to be of type double. So double A, and we're going to default it to 1. Okay, and we'll also go into here and sets the activation coefficient. What we'll do is void set activation coefficient, and it's double, and we'll call this x as well for now. Actually, we'll call it value in. We'll keep the same naming convention I've already been using. Okay, let's refactor. And all this is a equals value in. Okay. So let's go back to our math utils. We have A there now. In fact, most of these are going to use A. Next, we'll do inline double act sigmoid, and we have double A double X, where we do return 1 divided by 1 minus exponent negative A times negative A times X. Okay. And then finally, inline double act hypertan, which will take double A double X. And in this, we do return 1 minus exp negative A X divided by 1 plus exp negative A times X. Okay, so those are our base activation functions. Also, I forgot to turn the cam back on. There we go. So those are our base activation functions. If we return to our Neuron master class file, what we can do here then is we can do output equals umath act step, and we're just passing into this one our raw output. So output before activation. All right, this one, it's output equals umath, and this is act linear, and this needs A and then our double, so it's A, comma, output before activation. Okay. There we go. And I'm just going to copy the argument, because the argument's going to be used repeated through the rest of them. So this would be output equals umath act sigmoid. Okay. And this is output equals umath act hypertan. Okay. And then we're going to take the act linear here. No, sorry, the act sigmoid. We're going to copy the act sigmoid and paste it for our default. Okay, so our activations are now done. We can actually have returns here instead of breaks, but we'll leave it as breaks. So that is our output. Okay, so we have set output. Okay, so related to that, we are going to want to get our number of outputs. We're going to want to we're going to want to get our outputs. So let me just line this back up so I know what I'm looking at. Okay, so then we have our output getters. Okay, so for the first one, we're going to do inline double get output const return output. Actually, what we're going to do is returns activated output, returns output or raw output stroke output before activation. So we'll do inline double get output before activation const return output before activation. Sorry, output before activation. Okay. Also, we want to know how many outputs we have. So get or returns. And if I'm not staying with some convention there, returns the number of outputs. So this will be inline uint 32t get number of outputs. So for this, it's const return number of, oh, sorry, we're doing output as one, not as a, I'm thinking about the layer again. Ignore me. Ignore me. Sorry about that. All right, so what we'll do instead is weights. So we want to returns the weights vector. So this will be inline std vector double get weights vector const return weights. Okay. After that, what we'll do is we'll get an individual weight vector. So this returns weight. Sorry, I thought I had done one of these earlier. I was just going to copy it. Returns weight at index I. Okay, so this will be inline double get weight singular with an argument of uint 32 t I const. Okay, const return weights at I. Okay, let's compile, make sure we have no errors so far. Nope. Okay. Let's see, what else do we need to have in here? Sorry, I'm just looking at my notes. We have the training one that we aren't going to fully set up, but we'll have it ready for use, which will be our update weight. And we're going to do 2 for that. We're actually, well, we have set individual weight somewhere, I hope. Set output, get weight, get output, get weight. Before activation, individual input, set individual weight. Okay, so we already have part of it, but it does belong there. We're going to have another part down here called update weights. So set an individual weight value. This is done by the system at runtime. So in theory, there should be no error thrown for this one. This is void update weight uint 32 double value in. Okay, let's go ahead and define this. That is not what I meant to click. Okay, and for this, all we're doing is we are going to find the weight at a particular index, and then we are going to update that weight at that index. So we're going to try to make sure that we have to make sure it's in the range still. but we're not going to get an error otherwise. So all we're going to do here is check if it's in the range of our weights, which will range between 0 and the number of inputs we have. Inputs. I had to say inputs. Alternatively, what you could do instead is I is less than weights dot size, but I'm going to do it this way. And then what we'll do is we'll do weight I is equal to value in. Okay, there we go. Let's build again. And I think that covers all the functions I wanted in my neuron. I'm pretty sure of it, actually. So next we're going to go up to do our layer. So let's go ahead and in our layers folder here, add new item. And this will be our neural layer master. And let's go to our layers here and add a file. This will be our class file of neural layer master. Okay. Next, what we're going to do in here then is we'll do an include, and then we'll go back a few folders into our includes, into our network, into our layer, and into there. Okay. And then I'm going to pop over here, go to the very top of this thing, grab this, and I grabbed the wrong one actually. I meant to grab the one from here because it has my usual sort of neural layer class declaration. So what this one will be doing is this class is the file for the neuron layer, a parent class for input, output, and hidden layers. The layers store the neurons, collate inputs and outputs. Okay, so there we go. Right. So what we need here is we need, well, constructors and destructors, clearly. So let's start with me just cheating and going here and just copying this bit. I'll change everything up in a second. Yes, I'm being that lazy. You are free to judge me all you want for me being that lazy. Sorry, I don't know why I had the urge to check if I had done that, but hey, there we are. Okay. And I'm going to make sure to actually get the names right this time. So this is our neural layer. Actually, I'm just going to name it neural layer. The master, that is the class. The master file, so I know what it is. Okay. And we're going to change that out to neural layer and that out to neural layer. Okay. So for our attributes, what we need is a vector of the neurons, which we're going to store in a private scope. So this will be std vector and neuron. Neurons. So my tells me I need to include something. So we're going to go into include. We're going to go back one folder. We're going to go into neuron, and then we're going to include neuron master. And now I can declare that class. All right. So these are the vector, or actually technically it's an array, even though it is a vector, but we're doing it as an array of the neurons stored in this layer. Okay. Now, I was calling the weights a vector, not because they're a vector, but because we'll actually be looking at them in the sense of a 2D vector and 3D vector. So they are actually vectors in the literal sense, not the coding keyword sense. Whereas this is an array of neurons in the definition sense, but in the coding sense, it's a vector. Fun, I know, right? Try reading this literature talking about arrays and vectors and not having it match up to your definitions in C++. Oh my god, it's fun. Okay. We'll ignore the fact that I nearly cracked there for a moment. All right, so, right, next we're going to do our protected. And we want to know how many neurons are in this layer. And we're going to use uint32 again. And we're using uint, so unsigned integer, because this should always be a positive value. Number of neurons in layer. And we're going to default that out to 0. So now we're going to have a weird one. We're going to kind of reference ourselves here. Now, we're referencing the same, our class here, but it's a different instance of the self. So this is the layer prior to this layer. This is a layer that feeds into, or I'm going to say the layer that feeds into this layer. Sorry, I had to keep the wording consistent there. And so this is going to be neural layer as a pointer. We're going to call this previous layer. And we're going to default this out to null pointer. Okay. And then we're going to do the same. This is the layer the layer after this layer. This layer feeds into that layer. Actually, I'm going to change this up. The layer that this layer feeds into. There we go. And so that's going to be neural layer, again, as a pointer. Next layer. And this is null pointer. Not null. Null pointer. Thank you. All right. And then we need our arrays of inputs and outputs. Actually, technically, they're vectors too, depending on the setup of the network. It can actually be either a 1D array or a 1D vector or 2D. But yeah, they're vectors. They're actually vectors. So we then have the input vectors from the previous layer. And this will be std vector double. And those will be called inputs. And we're not going to worry about sizing it or anything. We'll take care of that later on. And then we have the output or inputs vector. The outputs vector from this layer. Okay. And this is std vector double outputs. And again, we'll worry about sizing it later. Then we're going to do a weird one. Actually, we're going to do that right between previous and next, just because this makes sense to me. A reference to self. We're going to do neural layer self ref, and we're going to define this one as this. We're looking at ourselves here. This is just useful when we're passing in certain arguments, when we're making comparisons between different layers and making certain arguments. We're not going to really use that one for a bit. We might touch it a little bit later today, but overall, not really. No, we'll do other things. Okay. We're gonna need to think about the activation methods and things like that. Oh, you know what? I actually am skipping one. We need to know the number of inputs that this layer can receive. And so this will be a uint 32 number of inputs. We'll default it out to 0. Again, the thing should crash out if it is 0, or delete itself if it's 0, because that layer isn't doing anything. Actually, no, there are some cases where you might have self-organizing ones where the layer might not actually be receiving inputs. It might just be generating random data. Fuzzifiers that might do similar things, so that actually could legitimately be 0 in some cases. I'm just trying to think if I've ever seen it. Conceptually, yeah. Okay, so that is our attributes, and we can go on to our methods. And yes, I am going to be my normal lazy self here, and I am going to copy that. And I actually bit my tongue while talking, so that is why I'm sounding weird. Speaking of which, ow, I really bit my tongue very hard. Which is hilarious, because to me this song is about pterodactyls. And I just think about pterodactyls biting things now. Don't ask. Just don't ask. That's all I'm going to say on that one. All right, so, right. We want to build the layer, initialize the layer. So this one is a bit tricky because I'm trying to think about the fact that I know there are going to be 3 other classes derived from this one, and what belongs in the parent class, if everything belongs in the parent class, and they're called up differently in the children, which I'm thinking is the route I'm going to go. Yeah, it has to be done that way because there's overlap between all of them. It's as I said earlier, the input neuron or layer and the output layer have half of what the hidden layer has. So the hidden layer is going to have both parts. So, I mean, I could make it so that the hidden layer only has its parts, the input layer only has its parts, and the hidden layer is derived from both. That is an option. I don't think I'll be taking that option today. So, I'm honestly just okay. First, these that should actually be virtual because we are doing be deriving classes from there. We might override it. I haven't decided yet. Next, we're gonna do virtual void build layer. Okay, so when we build the layer, what we need to know is the number of neurons in that layer. But we're going to start with that one. Okay. So we're going to copy that for now. Okay. Which means we're going to set, we're going to have a void, because we're not going to override this one potentially. And this will be set layer depth. And that's also going to take in that same argument. Okay. Let's go ahead and define both of these. Actually, I should be able to do it. Oh, really quickly, that should be uint 32t and uint 32t. Okay, should be able to define both of these in one go. Yep, there we go. Okay, so for set layer depth, what we are going to do is number of neurons in layer is equal to number of neurons in layer in. And then let's go back here for a second. We're going to want to resize our vector. So neurons, clear, neurons dot resize. Okay, there we go. So the first thing we do then is set layer depth, and we're just going to pass that argument down there. There we go. Just going to build, make sure there are no errors so far. There are not. All right, so sets up properties for layer. Basically, we're doing the constructor, but because we don't know it's actually, oh, speaking of which, we should probably have the actual constructor in there and the destructor as well. Okay. So we've set the depth. The next thing we're going to do is the number of inputs. So that will be a uint 32t, number of inputs in, uint 32t, thank you. Copy, I meant to get the comma too. Copy all of that, bring it over here, paste that in, and this then will be our number of inputs equals number of inputs in. Okay. I'm just trying to think if the activation method is going to be passed here or not. I'll make that decision in a couple of moments. Instead of thinking about that, we're going to initialize the layer. So similar setup to the neuron itself. I feel like we're trying to do some alchemy here. As above, so below. Where we did the build and then the init. So we'll init layer this time. And this is a virtual void of init layer. Okay. So sets how many neurons are in the layer, and then this initializes the layer. Also, these are all related, so I'm going to group them like I normally do. So let's just define this now. Sorry, I'm having a hard, my tongue really still hurts from biting it. I'm sure someone's gonna hear that in the VOD and just go, what the hell is wrong with this person? But yeah. So what we're gonna do now that we have this declared is we're gonna check that there are actually neurons in this layer, because if there aren't, this layer shouldn't exist. It wasn't inputs, like I said earlier. It's the number of neurons that determines, does this layer actually exist? And it needs just one neuron. So what we're going to do is we're going to check if number of neurons, wow, I am having one of those moments still. Number of neurons in layer is greater than 0. Then we're going to go through our initialization of the network. So this is where I tend to run into bugs in writing my networks, just as a heads up. But before we get to that point, we're going to do an else. And the else will be this. And then we're going to destroy it, because it shouldn't exist. There are no neurons here. We don't want this thing clogging up space and memory. No. Bad. All right. So for the actual initialization, we are going to go through each of the neurons in the layer and build and activate them. So we build the layer, we init the layer. As we init the layer, we then build the neuron. I went to the wrong one. Build the neuron and then initialize the neuron. Right. So what we need to do is, I'm just trying to think really quickly if I want to do it a different way than I'm planning. We're going to do size t. This part is the same, by the way. I is equal to 0. And then we want I is less than the number of neurons in the layer. Then we will increment I. And this is the part where I'm just thinking about it for a minute. This is the part I always struggle with, and I have like 5, 6 in my notes. 6 different ways I've approached it before, and I'm trying to determine based on my notes which approach I want to use. And I'm almost tempted to say sod it all and write a new approach right here and now. But I'm going to avoid doing that just for a bit. Okay, first what I'm going to do, just so I don't have to jump back and forth between things, is we want to, it's number of inputs activation method. So we definitely need the activation method in here somewhere. So we need to get the same include in here. So that is include, and then we're going to go back, there, and there. Okay. We're actually going to set this in the private attribute, and this will be the activation method, and then activation method with the lowercase e, and we'll default this out to activation method sigmoid. I put the terminator in the wrong spot. Okay, so there is our sigmoid call for our activation method. We will create a method for this actually right here, and this will be sets activation method for layer use, and it will be void set activation method, and it's activation method method, or method in is what I think we called it last time, and I'm just going to double check that is what I called it. It doesn't really matter. And that is here. It is method in. All right. And we then are going to also add this as an argument here. Let's go ahead and define this. Let's go back here to work on that definition instead of doing it in there, because I want to just easily find that spot and paste that in. And then we do activation method, the variable lowercase e, is equal to method in. And then in here, we're going to do set activation method, and then method in. Yes, I realize I could have just literally did what I did up here and write one thing for it. It's because it's private. That's the only reason why. All right. Next, let's go back to our, there it is, here, and to our setting of the neurons in that layer. What we're going to do here, sorry, this chair is busted and it's driving me up the wall, is we're going to create the neuron, we're going to build it, and we are going to store it. So we have to init neuron, and declare it technically. We actually, let's just say, let's use some different words here. We have to declare stroke construct the neuron. We have to build the neuron. And to make it even clearer what I mean by build here as compared to declare and construct, I'm talking about the function we wrote. We then have to init the neuron. And then finally, we have to store the neuron in the neuron's vector. Okay. So, chat, I have literally 5 methods on the screen next to me. I am not a fan of any of them. Chica, if you're still around, I think you helped me write 2 of those methods. I can't believe both of us missed the error that led to why we had so many versions, or why I had so many versions. So, chat, I honestly am really torn on how I want to do this. I am tempted to take a very practical red-green cycle approach to this. Currently, we're on red. I have a list of the things I needed to do. I can make functional code that will do those things. Will it be the most efficient? Probs not. Definitely not. But it will work. So I could approach it that way. And we can move on and be happy and test out other parts of the network and come back and rebuild stuff. And I'm clearly rubber ducking you right now if you haven't worked that out. Instead of rubber ducking around coding, I'm rubber ducking around my design choices. And I have clearly reached a conclusion based on how I phrased that. And if you haven't worked out what that conclusion is, literally everything I just said, we're doing the red-green cycle. I'll do it in the most pragmatic, simplistic way I can, each of those steps. It won't be efficient, but it'll work, and we'll come back and clean it up later. All right, so what we're going to do here to do that is, well, let's first declare and construct the neuron. In fact, I'm just going to do it to the side of the comment. So we're going to do neuron, and then we're going to do neuron local as its name. So class, variable. We then need to build the neuron. So we're going to do neuron local dot build. And what are our arguments for build here? Really? So we need the number of inputs. So we have that. We have number of inputs. And we need the selection method. So that was E, activation method, the lowercase e. Oh, comma. You only asked for 2. And then we are doing neuron local dot init neuron, which takes no arguments. And now we need to add this neuron to our vector. I'm just going to give a space there because that is probably where we're going to reduce everything down to do all these steps in one. Sorry, I'm just thinking about something for a second here. So what we'll do for that is neurons dot at I is now going to be equal to neuron local. Okay, let's build really quickly. That's what I like to see. Okay, so there we go. Okay, I don't like that, but it's simple. It's pretty enough. It does its job. Hopefully, we'll find out. Again, that's the function where my networks tend to go. How do I politely say crash and burn? Yeah. Okay, so we have initialized our layer. Now, we have set layer depth, which is resizing the number of neurons in the layer. We need to think about alternative ways of setting neurons. So we will have a set singular neuron as compared to set the neurons of the layer, or the init of the layer. So this is if we're going to just actually build a neuron and put it in a network kind of thing, or into a layer kind of thing. So this is going to be a little bit of a weird one. My tongue still feels thick. So set an add an already created neuron at this layers at index I in this layer. So this will be set void virtual void. Nope. I'll do virtual void just in case. Set neuron, and then it's size t. Give me a second, because I don't think I've been using size t for that, have I? I've been using uint 32. I could be using size t here. Sorry, I didn't realize I should have probably have seen which one I changed. Which one did I change that on? Set individual input. And this is all math utils. Okay. Why did we fail? Okay. There we go. Yeah, we will use size t's because these are indexes. They should be size t. So size t. And that was update weight. There we go. Set individual weight. Set number of inputs should be the same. So set individual weight. Set individual input. Set individual weight. Make sure everything still lines up. Which one failed? Okay. There we go. So that should be size t, I, and then this is where it gets funky. Not really. Neuron, and this is going to be neuron in. Okay. Let's go ahead and create this function. And yes, I know I'm doing virtual again. We can override them. But I'm just writing out a base function in case that is the function I end up needing. So this is set neuron. And what we're going to do is try and catch. We'll put the argument in there in a second. And then we're going to do neurons at... Actually, I want to see how I did it in the neuron really quickly. I didn't do the app. Okay. No, I did not do the app. So I'm just going to do neurons I is equal to neuron in. And then throw, I think it was 0, 0, 3 I'm on. And that was, you know what, the neuron master? Yeah. Sorry, just making my notes to myself about where I'm tossing these throws in. All right, and I'm going to actually head back here to the neuron master for the catch. And I'm just going to copy this. Come back here. I was doing that in the header. Jesus. I hate using that window when I'm streaming. All right, so we're going to keep the same const. We are going to do the same thing here. And we are going to need to have included the standard exception and include the several folders back. What the heck is going on there? All right, so 2 folders back. What the heck? Oh. Yeah, I see the issue. Okay. I definitely did not think that one through. And actually, this is going to get moved up here. All right, so that should resolve that one. Cool. There we go. We can get rid of that. So now that we have our set neuron. Oh, hang on. Yeah, also we're going to do the attempt of neurons dot pushback, and then we're going to pass in neuron in. Okay, there we go. Let's say I know each one of us should have 2 lines, so I was like, why is there only 1 line suddenly? All right, we've set the depth of it. We are going to have one function that is just strange to have. In fact, actually, we're going to call this up fairly early as well. Kind of skipped this one, which is, this is just going to be void. Set self. Yeah. So this is literally just going to set a reference to self. And all we're doing here is ensuring, this is literally just to ensure that this thing has correctly initialized. And it's just going to be if, and then self-ref. Now, you could do this in 2 ways. You could do if self-ref, and this is the case we're looking at it being a null pointer, which is what I am more worried about happening. If you are worried more generally, the null pointer, is it actually accidentally assigning to the previous layer or the next layer or some other layer that doesn't exist instead of to the self, you could do if self-ref does not equal this instead. But I'm not worried about setting it to the wrong thing. Great, now that's going to be the bug of today. Just watch, that's going to be a bug today. I'm worried about it being a null pointer by mistake. So we're going to do set self-ref, or we're going to take self-ref and set it to this. Right, so we're actually going to do that when we build the neuron. So set self, this is literally just a double check that the neuron is, that the layer is correctly set. And it correctly recognizes itself versus the other layers. We're talking about sentience and our layers of neurons here, ladies and gentlemen. You've heard it here. Okay. So next we have we're still in the setup stage of things, but I am going to put some space there because of what we're doing next. And we are going to set our layers here. So it's virtual void set previous layer, and that's neural layer, layer in. And we then do virtual void set next layer, neural layer as a pointer again. And this will be, of course, layer in. I'm really tempted to name that one layer out as a joke. So this sets the next layer, or sorry, the previous layer. And this one sets the next layer. All right, now, do we want to actually define these here or define them in the appropriate classes? For now, what we're going to do is leave them as undefined functions so that we can just override them in the children. In theory, I realize that should be with them, but it's just in my head, this is the easier way for me to understand it. So that's why I'm organizing it this way. You feel free, if you're following along as I'm doing this, to organize it in your own way. Or if you're watching this very long VOD at 4.5 hours. Sorry for the silent first 10 minutes. I'll see if I can edit that out. I have to figure out how to edit VODs. Yeah, so we have our next and previous layer set, our depth, we've initialized it, we've built it, we've set our self-reference. We now need to do our calculation for that layer. We need to get the previous layer, we need to get the neurons, we need to get the activation method, we need to get individual neurons, we have a lot to do, clearly. I'm just trying to think about this. I'm thinking about this in the methods of doing things, so the setters, and then we'll come back and do the getters afterwards. So we need to calculate the layers output. So what we'll do this is virtual void calc with no arguments. We will define this one. I mean, we'll properly define it, not just do an empty define like I did a second ago. Okay. So what we'll do for this function is we need to take all of the outputs, the ones with the activations, and we need to store them in our vector of outputs. We need to pass that on to the next layer, where that vector of outputs becomes that layer's inputs. So I'm just trying to think how we're moving from the inputs to the outputs in the layer. We're going to do the same thing we did in the neuron, actually. So if you remember in the neuron, when we do our set outputs, we do these checks, right? So we need to go back a step and fix an error that will come up. Notice we're using vectors. Actual, like, C++ vectors in this case. Coding term vectors. We're using C++ vectors. We have sized our inputs. Oh my god, please tell me you have done that, or I'm not losing my sanity more than I thought. Number of inputs. And then set layer depth. Okay. Set layer depth is the number of neurons. We've set that. Number of inputs we've set. Okay. So what we actually want to do is also resize our outputs. And what we'll do is we'll do that under set layer depth here. And we'll actually get rid of the number of inputs. So we're going to set sorry, I'm just thinking I've done something wrong here. I have. I was really confused why it was number of neurons, and okay. Yeah, those are completely different things. So set layer depth will also cover our weight as well. So we're going to do in here. No, because I might want to call it up separately. No, that's bad. I would rather have more than one function. So when we do set layer depth, we are also going to adjust or sets the weights vector based on layer depth. So this is void set weights. Not set weights, because I'm not actually setting the weights here. We do that later on. Actually, we do that in the neuron. So what we're doing here is we're setting the weights vector. And we won't need... Ooh. No, we will take an argument for this one, actually. So the number of neurons in the layer is going to determine the number of weights coming in, I think. So let's take that, pass that into there. All right, let's then define this. And all we're doing here is literally what we did above. We're going to, do I actually have a ding for that? Like num of weights? No, I don't. Okay, cool. So number of neurons in layer. What we're going to do is we are going to take our weight, take our weights, wait, ignore me for a second. I'm doing the same thing I was doing a while ago. I'm mixing and matching the neuron and the layer in my head. It completely ignore me. We did catch a mistake, though, at least. There was an actual typo because of that. We don't need any of that. Okay. Yeah, that should have been number of inputs still. So, hey, at least me going off the rails there, you know, we found something. All right, so what we're going to do is check. Let's look at our neuron for a moment, and hopefully I won't get confused again. We're going to check if the... Where is my example in here? We're going to do this sort of check here. We're going to check, are there actually neurons in this layer? And are there inputs? If there are, hey, we're good to continue. So what we want to do is, we could do it as two checks with, you know, one by itself and then two below it. But we're going to do it as one because we can mix two of them into each other, which is, are there neurons? We don't just need the number of neurons because we can also fudge that data a bit and screw things up. So we're going to do is inputs not empty and is neurons not empty. If it is, then this layer is valid. Okay. So what we're going to do then is we're going to iterate through each of the neurons in the layer. So for size t, I is equal to 0, and I is less than the number of neurons in the layer, which we have already set earlier. We'll double check that in a moment. No, we already did double check that. Then we will increment I for our loop body. Also, yeah, that should be a 0, not an O. I'm sure somebody watching this on VOD is screaming. Actually, I'm sure there are other things they're screaming about this video. Right, so there's that. And next what we're going to do is we're going to take a look at our neuron. Actually, let's go back up here for a second. We have built our neuron. We have done the init on our neuron. So now let's go to look at our neuron. We've built it. We've done init. We need to set the number of inputs. We need to set the weight vector. Actually, hang on. Let's just go back here for a second. See what we've called up. So at this stage, we have built the neuron, which means we have done the number of inputs. We've initialized the neuron, which has given us our weights. Sorry, I think I don't call... Oh, wait, no, I do call it up. There it is. So when we build the neuron, we do set the weight vector. Okay, good. So we build the neuron. So we set the number of inputs. We set the vector weight, or set the weight vector. We set the activation method, which is all the way down here. Okay. We have then initialized the neuron, which means we have done the weights random. So now we need to do the inputs and outputs. So let's go back here, and we have set inputs. So let's take a look at our set inputs, even though we just wrote it a few minutes ago. All we're doing is looping through and passing the input value in. Okay. So we are going to go to neurons at I, and we are going, actually we're going to do neurons I dot set inputs. We're going to pass in inputs. Because I didn't do this as an array, I did this as a vector on the end. Okay, there we go. Build it really quickly. Find that error. Build it again. Okay. Now, let's just go back here really quickly. Yep, that works. Okay, that should work at least. And then we are going to calculate the output. So we'll do neurons at I. And then it's set output, which requires no arguments from us. So let's take a look at set outputs really quickly. So all we're doing is creating the individual outputs and then before activation and then passing it over to the math utility function to get the output for our particular one. Okay. Now what I want to do here is see what I've done with my output so far. I've done nothing, which is going to give us a bug. Okay, I knew something was bugging me. Like, we hadn't resized one of them. I am so glad I got that paranoid because I would have missed this for ages. So we need to resize our number of outputs. And the number of outputs is equal to the number of neurons in this layer. So they're tied together. They are one and the same. The number of neurons and the number of outputs are almost always the same. There are some models where they aren't. There's fuzzy models I can think of. Actually, the Wikipedia has for fuzzy models has a picture of one if you don't believe me. So what we'll do here inside our set layer depth is we're going to take care of our outputs as well. So outputs clear, and then outputs dot resize, and its number of neurons in layer. There we go. Okay, just build that, make sure we have no issues. So now that we've resized it, we can add it to our outputs. So what we're going to do is outputs I, which does not exist because we're no longer in that loop. Sorry about that. Outputs I did it on the wrong line, is equal to neurons at index I. Actually, sorry, I like doing it at I on this side. Dot get output. Okay, there we go. So we are now storing the output. Great. I'm trying to think if there's anything else that we need to do before we get to the getters. So we have calced, set layer, set inputs. This is the order in which they're on my screen. Built layer, set depth, set activation method, initialized layer, set self, got previous or set previous layer, set next layer, calc. Yeah, we're on to the getters. Okay. So I'm just gonna again go over to my header here, and I am gonna do the same thing I did before. Set up setters, set up getters, etc. So okay, those are those things. Okay, let's do that. Move that there. And move that there. Okay, so we're gonna start with these are public. This is definitely private. I am considering private or protected for this one. Okay. Let's go back here. I'm not sure if we'll have any of these, but if we do, they'll go there. Okay. Then our output. Oh, actually, I put that in the wrong spot. That goes there. This is protected. And then we're on to our getters for our setup. There we go. And I'm going to copy that, paste that down there. Oh, I'm clearly waning. Can't you tell? Can't you tell? Can't you tell? Right, so with that set up, we're doing our getters. So we want to get the number of neurons in the layer. That's fairly easy. So we'll start with that. And this, I realize that's not about setup, but it relates to where we do it. So returns the number of neurons in this layer. And this will be a inline uint32. Yeah, uint32 get number of neurons in layer. Const return number of neurons in layer. Right. And then we want to get all the neurons, so that will be returns the neuron vector list for this layer. Not sure why I've randomly capitalized some letters there. So this is fairly simple as well. This is inline std vector neuron type, and it's called get list of neurons. Const return neurons. Okay. We will want to returns previous layer. So that will be neural layer. Neural layer get previous layer. Const return. Do we actually ever? We did. Okay. Previous layer. Oh, I see. Previous layer? Oh, yeah. Sorry about that. We're actually going to do something else. Oh, yeah, we'll do this here. So if previous layer is not equal null pointer, return previous layer. There we go. Okay, we're going to copy this. Returns next layer. So if next layer is not a null pointer, then return next layer. Okay, there we go. Oh, this is set previous. It should be get previous. Get, there we go. Okay, I'm gonna just quickly build after that. Okay, so that is that. It is related to the output, but we set it on input. We'll do returns activation method. So this will be activation method get activation method const return activation method, the lowercase e. And then We're going to go back up here before previous layer. And also, these should all be inline. Okay. And then we're going to return an individual neuron from the vector at index I. And this is inline get neuron size t I. Inline neuron. Return. Nope. Const return. Oh, I am flagging. I am so sorry about that. Neurons at I. Don't ask. Okay. There we go. I don't know what I did wrong there, but there we go. All right. Right. That's in the neuron, the output. I meant to say layer, but output. Okay. Thanks, my sleep-addled brain. You're seeing things that my brain isn't seeing. Right. Okay, so seriously. We need to return the outputs. I had to think about, again, not confusing my output for my outputs. Plural versus singular version. So we are going to return this layer's vector of outputs. All right, so this will be inline std vector of type double. Yeah, of type double. Get outputs, and that will be a const return outputs. Yes, I seriously was struggling to remember the name of the variable I said like 20 times in the last 3 minutes. Yeah. All right, next returns an individual returns outputs output at index I. So inline double get output singular size t I const return, and then that's outputs at I. All right. Sorry, I'm not explaining the really simple functions I'm doing. If you don't understand a getter and setter, you need to do the other tutorials, not these live streams. At least not this part. This, if you want to watch, go for it. If you want to try to do osmosis for it, go for it. Honestly, it actually does kind of work. You're absorbing material even if you don't realize what you are. As long as you're paying attention. It doesn't teach you the content, mind you, but it will make you more comfortable with it. Right, so I got activation method. I got neuron. I got output. I got next layer. I got previous layer. I got activation method. I think I already said that one. I got the list of the neurons overall. I got the number of the neurons in the layer. That takes us through the primary layer. Now we have the input, hidden, and output layers. So I need to take a couple-minute break just to stand, stretch, feel somewhat human. So what I am going to do is I'm going to leave the music playing for a bit, and we will return to working on this in about 5 minutes time. All right, I will be back shortly. I'll leave the music on. Has it been muted this entire time? Lovely. So sorry about that for anyone listening. So what I've just said is, I am, it's all the time. It's late at night for me. It's 11 something here. I haven't had dinner yet. I'm switching from the neural net project, which will continue the next live stream, to working on the game's engine code. I have muted the audio from my computer because this code isn't mine. It isn't my content I've created. It isn't my tutorial. I put a link in the chat for it. And what we'll do is we'll do the tutorial together. I put a timestamp, link to that tutorial from Game Engine Programming. We will be doing it from the timestamp there. It is their work again. What I'm doing with this is I'm going to do multiple Game Engine tutorials before I try doing one on my own. So, again, not my content. Please go subscribe to Game Engine Series for doing this work. And yeah, we'll start with that. I've committed the neural network. I put the link in the description. There was a bit of a pause where I was talking about trying to find the copyright stuff, but I'll take care of that later. So I'm just going to start by looking at the tutorial. And I'm just making sure that it's not doing anything else. So creating a new project. And I'm just checking, making sure the sound is correct now. Okay, you can kind of hear it through the headset. Sorry about that. I'll have to lower the volume. All right, so I'm going to start now. So we're starting with the static library. This will be called engine. I'm just following what they're doing. And we're going to just drop this into here. And we'll do, oh, no, we already have another folder. Okay. So this is from Game Engine Series. And we're going to use the same names they use. Yeah, now I need to update. So we're going to create the editor first. And to do that, we will do add new project. That'll be WPF, so Windows .NET Core. Okay, so he wants us to use WPF application, C#, Windows Desktop. We don't want Visual Basic. Okay. Okay, so this tutorial is a bit out of date compared to mine. We will use 3.1. Okay. There we go. He's doing it on x64, so we'll follow along on that. So we want to move parts, he said, so we're going to go to Configuration Manager. Well, I'm actually going to leave these in. I'm not going to delete them. Okay. So yeah, we're just building to make sure it works. So I just did that to make sure that my library is building because I didn't build. Yeah, we have an object of it. Excuse me. Yeah, it should be building a library. Okay. Now let's check. All right, I'm just going to follow along for now, see what's going on down the road, see if there's something we need to work out. I have a feeling this person has skipped a step in their tutorial. That's why. Okay. There is a library. I didn't skip a step. There is a way I prefer organizing this, so it would have made it make more sense to me, but that's fine. Okay. Oh, I see what he's doing. He's showing. Okay. Okay. I get it. Okay. So he's showing the same change I would be making. I get it. And he's showing. Okay. Sorry. Okay, so let's go to here. Go to Primal, x64, debug, and there's the editor. Oh, he's showing some little interesting tips and tricks. So, what we're doing is we're going to try to get it to be in the same folder. So currently what we've done it is, if we go in here into debug, it's in these two folders. He wants us to have it so these files are in here. And what he's doing is he's showing how to set directories up. Now, I'm not entirely sure how he's going to set them up, if it's going to be in a way I like. Because I know a lot of people who like having their libraries in a separate folder from anything visual. But at the same time, these two parts go hand in hand. So I'm not entirely sure how I feel about it right now either. I'm going to follow along, though, see how he does it, and work my way through there. So I'm going to go to here, and then we're looking for our Primal Editor C# project file there. So we're just going to open this up, and I'm actually just going to use Notepad. Yeah. So we can change where it is put here. So I think he wants to get rid of that platform bit. Oh, so we need to set something to stop it from appending the name. Okay, so that is append target framework to output path, and then that is false. Sorry, he spelled false wrong, so I'm kind of staring at it going, what? And then it is append framework target to output path again. And I'm pretty sure there's supposed to be a stroke here. And let me just resume what he's doing. Yeah, he fixed the typo, he added the stroke. All right, so we saved it, close it, and then build again. Okay. Let's go here to x64 debug, and there it's all in one folder. We have the original still. All right, let me just very quickly clean solution, rebuild solution. So now he wants to make sure that the editor project is the default startup. All right, so he's editing this in Notepad. I'm gonna follow along. Oh God, I'm actually really not comfortable with this part for some reason. No, the part that's why I'm not comfortable. I'm so worried I was gonna accidentally click that. Okay, so he just said switch these around so that this becomes a startup project. Okay, I'm not gonna close it and test it yet. Oh, wait. Oh, yeah, okay, so we just want to reload it. There we go. So apparently we're ready to start coding. Oh, hey, sorry, dear kitten. I didn't see your messages. And are also forms are WPF. WPF, I see like XML file, XAML, sorry. Yep, a stroke too close to XML. Yeah, I don't tend to work on the visual side of stuff, so I like following other people's tutorials for this. I'm a bit nervous how this is going because his organization's a bit different than mine, and I'm not nervous that it's a bad tutorial or anything. What I'm nervous about is I am going to have to spend more time trying to absorb the material and understand how pieces fit together. Like, the big picture makes sense to me so far. It's the little details that are going to make me go, why, how, where, when. I wish there was a way to make sure the chat stayed properly on my screen. I need another screen, honestly. Just have a screen of like 50 screens on there. Actually, I mean, I can only get probably two more screens, but they'd have to be on stilts behind my current screens. Yeah, this is going to be really kind of interesting to do. So what we're doing is creating a opening menu, by the way. So we're looking at either opening an existing project or creating an existing one. There'll be icons for the projects, screenshots for them, an open and an exit button. He's also talking about how these things don't exist yet, but sorry, I'm skipping through the logic of his stuff. He's just showing that there's templates for names, pictures of templates. Where are you creating it? Very much like the Epic launcher or the Unreal launcher. So I'm skipping to the section after presenting the editor, the project window. So that picks up at around 12:09 in the timestamps. Netcore 6 could be used for multi-platform, such easier than... So, yeah, that's something I don't know. I don't know much about the differences between the Netcore. I just picked 3.1 because it was the one that was available at the time. Here's the scary part. His version is so much older than mine that the options are very different. Like, yeah, I'm assuming he did this on 3.1, given that he doesn't even have the option for 6. Or a drop-down for the option. So we're adding a folder to this. Are we adding a folder or are we adding a divider? You did folder, okay. Because it's not in folder view, which is why I got confused. Ooh, I did not mean to click off of that. So, game project. Okay. Apparently the game project is going to be a thing in there and not a separate project. Oh, I see. Okay. So, it is... Hey, I have some horrible news for you, Dark Kitten. Truly, truly horrible. I am so sorry in advance for what you're about to see. Yeah, I apologize in advance. Please don't yell at me too much for what you're going to see in the next second. So, we're going to add... And we're going to add a window. And it's going to be for browsing the project. Why is it showing me class instead of window? Interface code. Okay. Okay. Did I click the wrong thing? I think I hit user control panel. Window. No, I hit window. Okay. I am missing the option he's using. So, hey, fun moment now. What we're gonna do is, so the reason why I said, don't hate me for what I'm about to do is he had an XAML file open on his tutorial, so I thought I was gonna have to open one. Apparently not, but, I'm gonna try to figure out what's going on here and figure out if I haven't installed a dependency by accident. So, yeah, we're gonna close out all of this. Sorry, I have a... Hey! The installer popped open. I like how that killed the stream for a second. Alright, so, yeah. So I'm looking for a window WPF. I'm trying to see. It is an XAML file, actually. The funny part is, I actually know I made one of them. That's literally the thing I had up earlier. I mean, I hate UMG work. I honestly hate working with anything graphics related, as you know. So I really shouldn't be talking. Like, this is, yeah. Look at that installer go. Dance installer. I haven't had dinner yet. I'm gonna be very hungry by the time I'm done with this. And it's gonna be very late. Ah, such is life, though. Such is life. Oh, God. Thank you, Internet, for being fast. Ish. With WPF, XML is actually easier to edit manually. Yeah, trying to code where things are going to fall, figuring out the vectors, the 2D vectors for them. That's all. First time I ever did any form of coding or scripting outside of like HTML when I was a little kid. Back like when I was 10. So we're talking before 2000s here. I did VRML coding by hand instead of using a 3D editor. Holy crap. Yeah. Also, that code is really weird because you set literally every pixel on screen manually. Yeah. I have issues. Oh, come on. Install faster. I'm just going to turn my camera off so I can have a cigarette while I wait for this to go on. And while we're waiting for this to go on, I'm going to turn the music back on. Feel free to continue chatting with me. I'm still going to be here. I'm just going to be cameraless. By the way, Dark Kidding, can you actually hear the music on? Ah, the taste of something bad for me. Oddly, it's NetCore 5.0 that's updating. Kind of find that funny, given what we're talking about. In the meantime, for anyone who's still here or who's still watching on the VOD, let's take a look at the remaster series for the RTS, just so I can be a bit of, have something on screen. RTS tutorial, Unreal 5. You can't hear the music. Oh, okay. Can you hear it now? So yeah, here's the updated camera. With our updated zoom. And our building system. Really? You can't hear it? My my OBS is showing that it's playing fairly loudly on the system. Oh yeah, you're right. The music isn't showing up. I can't hear it when I play my own stream. Right. Can you hear it now? I'm trying to figure out what's going on. Okay, well, that's strange. Wow, I've been playing music this entire time. Not sure why that's happening. We're still updating back here. Yeah, I'll take care of it in a different point then, and I'll just kill the music because trying to talk over it right now while I have it blaring is not pleasant. All right, sorry about that. I thought that would actually come through. It was earlier, I thought. I thought I updated yesterday. Apparently I didn't. Sorry about that. And to give you an idea also, the buildings will be slightly different. Now, I don't have it set up on the actual project file. This is the project file. But I can show you what we will have is we'll have buildings that get constructed in stages. So you'll go through each of the stages of the construction before you have the final build. Now I have prototyped this code. I know it works. And yes, that is the original barracks from the original series. I just thickened the walls of the other ones. Hey there, Tom. How are you doing, man? Sorry, we're waiting for my Visual Studio to update because I was missing an option. Yeah, I did 5 hours of working on a neural network set of code. There's a link in the chat. I'm not sure if you can see that far back, so I'll actually repost the links. So here's the code. I'm in the wrong window. Here is the code that we were working on earlier. Sorry, my thing kind of went crazy on me for a second. Okay. There we go. And yeah, now we're just waiting for Visual Studio to finish its thing. So showing off the RTS series remaster, what it looks like. And the various building sets we're going to have. Let me actually delete these off the map because this is the actual recording file. This isn't the prep file we're currently in. So yeah, if you're a Patreon subscriber at tier 3 or higher, you should already have access to these videos of making the setup. I've already recorded the time stuff. I just haven't edited it yet, so our usual... I swear I removed that breakpoint, but okay. Our usual time systems there with a nice little switch. Yeah, so that should be all there for the Patreon subscribers already. Oh yeah, I forgot. It looks really slow when you can't see the seconds. It's like, well, why is it going so slow? Also, one thing I really like about the system. It really does work well for slopes. I really like that personally. I enjoyed working on it. Actually, I really didn't. The code for it. I'm going to show you the code for that. It's in building master, I'm pretty sure. And that is this lovely function here. This bit in C++ is literally just 5 lines that are really simple. But to be fair, this bit, actually, all of this bit, I did not mean to do that. All of this bit minus the branch is actually a nightmare to do in C++. So, hey, some benefits to C++, some detriments in C++. Yeah. This honestly takes like 2 seconds to do in C++. This takes like 10 to 20 minutes to do in Blueprint. All right, Visual Studio is blinking at me. It's done. Now, I just want to make sure that I have the stuff for the... I'm going to add that in just because. And add that in. Yeah, I don't think I need anything else. All right, so we have a little bit more updates to do, and then we'll resume. And our system will only have one building master. There'll be no preview master, no nothing, and a manager. So it'll be a much more efficient system, by the way. Who here is actually doing the RTS series? And for anyone who's doing the survival series, just to show you where that's at in terms of the recording. At least that's going faster than the other one was. Oh, compiling shaders, so much fun. Yeah, the new series will be much more efficient, much faster in terms of how it processes things, and just a generally better system. I really am enjoying watching like this be pitch black for some reason. I'm just gonna switch to unlit. Oh, yeah, it is definitely compiling shaders still. Okay. Yeah. 1,600 shaders left. I'll be doing a different approach to the vehicles in the new series. I'm going to be avoiding the physics engine. Not because I don't want to work with the physics engine, but because it will actually make things a little bit better in terms of the unit selection and getting units to move correctly. You'll just need to add in your own animations for the wheel spinning, but in an RTS, you shouldn't be close enough to need that detail for the physics part of it. $50 shaders left. There we go. So for anyone who's doing the survival series, also let me make sure that OBS is actually picking up desktop audio, so hopefully you can hear the game. Oh look, we're getting a bit of rain. And hey, the ground's getting more specular also. So hopefully, yeah, you can hear the sound as well. I am working out a few glitches still with the swimming when it's raining. I am so glad there's no thunder or lightning, because that actually is really loud when I'm streaming. So the issue with the rain when you go into the water is the collisions stop working correctly. And we're now colliding while we're under the water. Also, I'm still working out that bug. Oh man, I'm really annoyed that you're not getting the sound effects. Like, there's wind, there's the rain sound, there's the sound of the ocean, the walking. I know it's in the tutorials itself, but I'm kind of annoyed right now that it's not picking up correctly. Oh, I haven't started working on the construction system yet in the recording series, but it's in the prep file. So when you hit tab in the prep file, it will start spawning in things for construction. So we'll have a construction system as well. Also, just so I can get rid of these clouds, I have a debugger active still in this. Visual Studio, by the way, is done updating. Sorry about the delay there. Let's go ahead and launch this back up. Close that out. Close that. Bring this back here. And let's open up this project, which for some reason opened in the other window. Yeah, I don't know why that sound is not working correctly. I am so sorry about that. So what we were doing at this point was we were adding a window to this. There we are. I didn't have the correct part of it installed. And Dark Kitten, I am so sorry. Please don't hurt me too much. I didn't mean to do it. Okay, so in all seriousness, I think he named this project. Browser project dialog is what he called it. Browser dialog. Okay. Wow, that took a good second, and it's still loading. Okay, that's not in the right spot, so let's move that into there. Okay. Let's now, anyway, I was just popping in to say hi. I need to get to bed before my wife decides I'm no longer welcome. Yeah, I know that feeling, given it's nearly midnight in the UK. So, have a good sleep. Apologies to your wife. Thanks for her understanding and all that fun stuff. Alright, what I'm not sure about is why I can't actually see it anymore. So I'm actually going to go ahead and delete that. And then I'm going to try that again. And it was project browser dialog. There we go. Okay. So we're going to stop it from being resizable. So resize mode is equal to no resize. And window startup location. So then we're going to, oh, hang on one second. Okay, so then we're going to the main window. Editor. So we're adding buttons to this. So we're going to make it so we can't resize it, but the screens will be in the center, at least the dialogue. So we're going to add rows in. So we're going to add a grid with row definitions. And we'll do automatic determination for it. So row definition dot, or height equals auto. And then we have underneath that row definition. Okay, and so we're adding in a stack panel. So stack panel. And then we'll have toggle button. Content, open project. Name is open project button. Hey, he's just someone recommended to me. I like this. And we'll copy this over and have one more. And there'll be new project. And then new project, new project button. You can see them up there. So we're upping the font size. Okay. And then we're adding a margin to this. So margin, and it's going to be 30, 0, 0, 0. And we're going to center these. So we're going to do horizontal alignment, and then we're going to do center, and then we're adding a margin again of 20. Ouch, being 1 a.m. there. So you just want to change the thing to create project. We're going to add another stack panel underneath this. So I'm just fixing some typo. So we're adding in a border, the width of 800, and then we're adding a background to this apparently. And we're going to just change the road this is in. So he's just going over his design again for what he's doing. Again, if you want to watch, I'm just going to post the link at where I'm currently at in the series, or in that particular video. So once again, this is the video we're at. It did go through, right? Yeah, it did. Okay. Okay, so in this, we're adding a text block. I'm actually going to follow his design on this because this is really hard to read on that size screen. Okay, so within this border area, we're going to have a closing border apparently. Or not. Okay. Within that, we're going to have a text block with a font size of 72. And the text will say open project. And then we have border. Okay, well, that's not looking like his. Huh. Cool. Give me a second. I'm just rewinding the tutorial bit. Okay. Give me a second. There we go. I wasn't getting that border bit I wanted. Okay. So now we want a text block. That was weird. Okay, let's go back to where we were earlier. Okay, so we've done one side of it. We're going to do the other side now. They both go in here. This should be light green. This will say project. And then we're going to update the margins. Not sure why I put a comma in there. That says a force a habit. And he did negative 800, 0, 0, 0. And, well, hey, looks like we have a different setup than him. Because I'm pretty sure that's not what's supposed to happen. He wants to shift them, so we're going to have to change our numbers up to make sure we shift in the same way. However, before we do that, we need to work out how to fix this other issue we're having. This covers the entire thing for him. So I'm just going to go through this. We have our stack or horizontal alignment. We have a margin of 20, font size of 32, margin of 30, 0, 0, stack panel end, stack panel start, horizontal alignment, grid row 1. I skipped something that he had, which is width. Had that in my earlier one, and then I left it out. There we go. Okay. So we're going to go to our main window. So we're creating a new function for when the window is loaded called loaded plus equal on main window. Give me 1 second. So on main window loaded, which doesn't seem to exist in my stuff. All right, let's see if we can find this thing. I think it's a function he's creating. Okay, I'm going to just resume watching. Oh yeah, no, it's a function he created. Okay. Oh, just screw this. I'm doing it myself, I guess. Okay. So this is C#, so private void object sender routed event args E. Okay. So loaded equals minus equal on main window loaded. Window only loaded once. It should not happen multiple times. Open project browser dialog. Okay, so let me just grab that, and this is private void. Oh, I hate C#. Okay, and so we're going to create a variable for the project browser, and we'll use the new keyword apparently. And this will be project browser dialog, of course. Give me 1 second. I just realized I reversed my letters on dialogue there. Did I update both of them? Yeah, and then let's go back to the am I blind? I'm just not. Oh, it is up there. I'm blind. Okay, so there we go. All right, let's go back here. And that's the wrong one. Let's go back here. And I'm just going to copy that name. What did I have spelled wrong there? Oh, I saw it backwards there. That's why. Okay. So we'll then do show. Oh, he actually didn't want to do an acronym for a dialogue. We should have watched this to see how he did this. Okay, I didn't rename any of them. That's so useful. There we go. Okay. Sorry, he was doing some edits on his thing as well. So I was just sitting there watching to see what he was doing. Okay, so So if project browser show dialog is false, and then we will do application. We'll do application dot current dot shutdown else Alright, fuck this. Pardon my language. What we're gonna do is we're gonna cheat. And we're just gonna re-add it. Hey, Kitten, you still here by chance? Because I actually hit a struggle point. I'm actually legitimately stuck. And I don't know how to, yeah. I'm gonna do the famous close and restart. Okay. Interesting. All right, Google. Initialize component does not exist. Okay, so I've encountered this a couple of times and keep forgetting what causes it. I ran into this when I renamed the namespace of my code behind file, but not in my XAML. I see the typo. There we go. And I now bet this will work, or not. Okay. Okay, that's right. Yeah, what the hell? Okay. Is it not part of the system? Am I... I'm almost tempted just to restart the project. What the crap am I missing? So we're in the correct namespace. What am I missing? Huh. I legitimately do not... I just realized my camera's still not on. Sorry about that. I legitimately do not know what I'm missing in this. Right. So, Hmm. All right. Again, famous close and restart. I legitimately do not know what is going on there. Okay. Thanks to the random C compiler error pop up there, Google. Okay. Literally do not know why this is happening. Like, also I had like 5 activation function windows open. Also that thing. Yeah, legitimately cannot tell you what is going on, why it's going on, how it's going on, and where it's going on. Right. Okay. Why? Just tell me why. That's all I want to know. Why? I had to do something really flipping obvious, and it's kind of driving me up the wall. So someone posted this as the solution, and yeah, no. Someone else has the same error. What button? So the solution in the comment is press the giant plus button. That is not a helpful comment. Okay. There we go. Here's the scary part is, that's what I was pasting in a minute ago that was giving me the other error. What the crap? Oh, I hate C# so much. Hey, look, there we go. Okay. Okay. We're back on track. So we're going to go over to the dialog window. And we're going to create logic for the buttons, apparently. I think it's going to switch between the two border windows we have. So we're doing clicked. Man, I don't like this person's style suddenly. On toggle button click. Now on toggle button click. And then he wants to copy this down one line. So we're just going to drop this down here, paste that in. There we go. And then in the project dialog browser C# side of this thing, we're going to come in and rename that because, yeah. Okay. So if okay, we're checking with the open project button. So what we're doing is we're switching between this one and the green one that I had up earlier, and we're also double checking, are we already in open project when we click open project? Are we already in create project when we click create project? That's what he's doing in this series. So yeah, I'll keep going, see how this goes. He's just repeating what he said earlier and what I've summarized. That reminds me of something. I'm glad I caught that mistake. So we're going to check if create new. Yeah, we'll rename that too. Okay. If create project button is checked. So we were in create mode. And then we're going to open project button. Create project button is checked, should be false. So we need to go back and give the panel a name. So X name, and he'll do it as browser content. So we go back here. We're going to do browser content margin equals new thickness 0. So this would be reverse, so open project button. This should be open project button. This should be our create project button. And this should be minus 800 pixels. So I think I'm a little bit ahead of where he's at, because, yeah. So click open project, nothing happens. Create project, click it again. There we go. Kind of cool. Okay, I like that bet. So yeah, I'm getting the same effect he's getting. Sorry, I am really flagging. It is nearly 1 a.m. here right now. Okay, so he's just repeating himself again on what the buttons do. Okay. Now I know how people feel on the end of my tutorials. Oh, okay. My brain, he said, oh, he wants to start with this selected and this unchecked. And my coder brain went, okay, we'll do it right here. Yeah, no. Apparently there's a better way to do it. Oh, that was... Oh, okay. That was a reality check I definitely needed after getting grumpy with this. Okay. And then this one would be is checked false. Okay. I have no idea if that's actually what he did. Yeah, okay, that seems to be right. Oh, I am going to have fun playing with this later on. Okay, so that's the end of... there's more to the tutorial. It's another 10 minutes. Okay. So he's going over the design. While he does that, I'm turning my camera off and having a quick cigarette. But I'm still here. I can still hear you. All right, so he's adding 2 more controls in. Where at thou? Okay, so add user control. New project view. Okay, and then one for open project view. So we're adding a stack panel to a grid, apparently. So this will be for the list of project templates and the screenshots in here. And so we're creating a list box as well. And then he's going to have a border for the holder of the image. And he's setting the alignment for that as well. And we're going to set the horizontal, oops, that's the wrong line, horizontal alignment to center. Okay. There'll be yet another stack panel. With a text box. Sorry, I'm just double checking my stuff now. Orientation horizontal, horizontal alignment center, 195, 250, 400, 250, 5. Okay. That's why that thing is bad for you. You should not be doing it. And we're changing the alignment on this panel. So we're going to have orientation, horizontal alignment. We're going to set to center. We're then going to go down a line just so we're on the same screen. And we're going to set a margin of 0, 30, 0, 0. Okay. And then he's going to have another stack panel, orientation, horizontal alignment, center, margin. You change that to 5 at some point. Okay. Oh no, that was 30. Okay. I see what he's done. He's copied his code. Okay. So what he did was he took this, pasted that there, and this became path with an alignment of 5. His is still way differently centered than mine. Ah. That's why. My margins were off. So you create a button here, content, and it's going to call it browse, with a width of 45 and a margin of 5, 0, 0, 0. Okay, and then he wants to create 2 more buttons down here to either open it or exit the window. Okay, so he took this line here. Okay, and then he created 2 buttons. Content, create, the width of 96. And 1 of exit. Okay. And we're going to make this the create button the default one. So if you hit enter, you don't have to click it, you just automatically does it. So is default is true. Is cancel is true. So we hit escape, it closes out. If we enter, it does create automatically. That's kind of easy. Nice. Simple. Good to know. Okay, hang on. I need to. He's deleted a good chunk from the project browser dialog. So he's taken the. I need to find the correct stack panel. Not this one. he's taken the borders here and here and deleted them. So let's just do that ourselves as well. And then, so we have local open project. So it's open project view, and I'll fix that in a moment. And then it's local new project view. I think that's one we were working on, and I am going to just come into here, fix this up. Go into here, fix that. There we go. Go back here. Nope. Go back here. Make sure that worked. All right, it's showing up on his, but oh. Okay, there we go. So in new project view, he wants to do width. That's gonna be 800. And again, we're going to do width 800. So let's go ahead and test it really quickly while he's still doing it on his side. Yep. Except for we can't see the bottom here. So he has the same error. He's now discussing that same error. So we're on the right track. Again, I forgot to turn my camera on after that. So we are inside of our project view dialog. And we're going to update that to 600. Now we're going to go to the open project. Sorry, the new project first. And we're going to take all of this down to here. Go to the open project. Switch the view around. Thank you, that was not useful. I think we got rid of the grid. There we go. Okay, so he goes from this stack panel down to the end of that stack panel. There we go. And this probably should say open. Okay, let's test it out. There we go. So hey, we have our launcher window open. We followed the guy's tutorial. Exit works though. Sorry, he just said as I did that, these buttons don't work, and I just had tested exit. So yeah, this is where he finished the video, and given how late it is, given how much I'm flagging right now, we will continue this at a later point. Like I said, these live streams will hopefully become a more regular thing. And those of you who have watched the VOD, thank you for watching the VOD. Those of you who are here today who have chatted, thank you for keeping me company. Thank you for being here. I appreciate you spending your time with me. And I look forward to seeing you in future live streams and in future tutorials. I hope that you have a wonderful day, and I'll see you in the next video.